Am I in? Okay, great. Thank you. And hello, everyone. My name is Nick Acosta. I'm a developer advocate for IBM, and I'll be talking today about something my area of focus in advocacy, and that's TensorFlow. So I'll be talking about TensorFlow, TensorFlow 2.0, and the IBM Cloud, how you can use TensorFlow 2 and IBM Cloud together. But before I do, I wanted to quickly touch on call for code. So this may be review for some. Just bear with me for a couple of minutes, but I wanted to discuss the call for code and our goals for the event, and that's to enable you to build a cloud, data analytics, AI, IoT, or blockchain solution to improve natural disaster preparedness, response, or recovery, and focused on health and well-being of individuals and communities. So you can see some of the reasons why. Here to the left, natural disasters are one of humanity's greatest threats, but while they may be inevitable, their impact can be reduced through technology. So Call for Code 2019 is our developer challenge that we will be hosting, and we're asking developers to create sustainable software solutions, solutions that are sustainable and open to prepare for, respond to, and recover from natural disasters. So you can see some of the benefits that the winning team receives on my screen now, some of our partners here to the right, and some link. You may be watching this on Call for Code's website, but if you aren't, there are some links to Call for Code here and how you can get involved. This is our second summer doing Call for Code, and you can see some information about last year's winner, Project Owl, on the screen now. So what we're looking to do for Call for Code, if you're unfamiliar, is really to take and extend beyond that sort of hackathon idea where we're getting people to create and have ideas and to really deploy and implement those ideas as well, and giving you as many resources that are at our disposal to help you do so. So you can see last year's winner not only using some IBM resources in order to get their project up and running, but also public and private entities that are helping them deploy this solution. And some more information on Project Owl you can see at this link here. Okay, so I'm going to be speaking for about a half hour today on TensorFlow, TensorFlow 2, and IBM Cloud. Wanted to go through an agenda for what I was going to be talking about. So you can see that I already discussed Call for Code, and again, thank you for your interest. And I appreciate you being interested in Call for Code, and I hope we can together help some people in adverse situations with these technologies. Be talking about basically the bulk of the presentation will be what is a deep learning framework, what is TensorFlow, and then what is new in TensorFlow 2.0, what you can expect and how you can use it, and our machine learning, deep learning, data science platform named Watson Studio. So TensorFlow 2.0. Before I get into that, we'll discuss what a deep learning framework is. So TensorFlow is a deep learning framework, and those allow for the easy construction of neural networks. So some things that they do is abstract away lowest level details. So I don't have to know some of the details as far as if I am programming out a neural network, how to get it to distribute across and maybe run in parallel on a system, things like that. So they will also standardize commonly used neural network concepts from just small components of a neural network into an entire model. So as I'm building out neural networks, I don't maybe have to describe what a method for changing weights in a neural network would be, maybe something like backpropagation. I don't have to recode that every time I'm coding out a new neural network as a deep learning developer. Or, I can leverage a deep learning framework to bring in an entire model to use that someone else has built that will include, the number of layers in that model, the number of nodes in each layer, and even the weights that are associated with all of those nodes. So there's a lot of components within neural networks that are reused, and standardizing those that they're the same, I'm using the same things that everyone else is really beneficial. And the third point that we can see here is to provide tooling for deployment on various hardware configurations. So being able to land a neural network on a number of different pieces of hardware, and then even non-standard hardware like GPUs. An example of a deep learning framework that I'll be discussing today is TensorFlow. So this is a deep learning framework coming out of Google via the Google Brain team. You can see a number of years ago in late 2015. And it was really built for the Google Brain team to leverage the unique position that they were in at Google at having just this large amount of infrastructure at their disposal. There are already traditional and pre-existing machine learning frameworks that they could maybe build neural networks on, but they weren't able to take advantage of distributing them and then using, and being on a Google team, almost an unlimited amount of compute. They weren't really able to extend the existing frameworks to take advantage of that. So that's where really TensorFlow is here. You can see this third point, built for distributed computing, able to leverage just all of that hardware at their disposal. You can see TensorFlow is a compound word made up of tensor, which is the default data structure in TensorFlow, and that's just an n-dimensional array. So that can either be a list or a matrix, or even something like a hypermatrix, even on more dimensions than that. And flow. So that describes kind of the execution that happens within TensorFlow. So you will write code in a number of different front ends, the most popular being Python. So you develop TensorFlow in that Python, and TensorFlow will translate that code into something like C++ or CUDA, depending upon the infrastructure that it's landing on. And it does so to build out a computational graph so that code can be distributed across a number of different machines. So it gets translated from what you're maybe writing in like JavaScript or Python into this code, into a computational graph at the same time, and that really increases the performance of TensorFlow. So we can see that was kind of here where the initial goal was to build and train these models in Python. And it's kind of extended in the years since to include a number of different programming languages and a number of different processes within the kind of deep learning pipeline, and to now a whole very large software framework. So that was TensorFlow. And then as of June 7th, so I believe it'll be 2 weeks from tomorrow, TensorFlow 2.0 was just released in beta. So I'm going to be spending a couple minutes here discussing what that means, why it's different, and maybe why you should be interested. So the two main tenets of TensorFlow 2.0 that make a difference from previous versions, you can see on the screen here, are usability, clarity, and flexibility. So if you take a look at previous TensorFlow versions, work was executed in sessions. If you're familiar with TensorFlow, you're familiar with the word session and the word a placeholder that you can both see on my screen. Those are hallmarks of TensorFlow 1 code, right? So where we would have that, what I was discussing, having TensorFlow translate my code or someone else's code into a computational graph so that it can run it in an optimized manner. So that was the default in TensorFlow 1. Now it is moving to a default where work is executed eagerly. So that means if I wanted to add, say, here I'm multiplying two numbers together, I'm squaring a number to be more specific. In TensorFlow 1, I would have had to define a placeholder to where I could notify TensorFlow that I'm going to have this variable, and then I could go ahead and add that multiplication operation and then run a session where it actually performs that multiplication. Now in TensorFlow 2.0, I just multiply two numbers together and I will get that output right back to me. Right, so that's just a way to make it more, when I'm executing this code, it's being executed in Python, and that's a way that where I'm seeing, since TensorFlow is so dominantly Python, I think it's used over 90% of the time. When TensorFlow is being used, it's just a way to make it more inline and more used to that Python developer experience, where as soon as you're coding some operation, you get the output of that operation. Another thing that is increasing the usability is the deeper focus and integration with Keras. So TensorFlow has now released their own specific and optimized version of Keras, and you are seeing that that is really, they're pushing that to become the standard for high-level model building and things like that. So we can see more of that in some of the examples towards the end of my presentation, but it's a higher focus on Keras and a more specific and optimized version of Keras specifically for TensorFlow. Another tenet is clarity. So if you look at the API tree in TensorFlow 1, if you just hit TensorFlow dot, something, you had 600 different paths that could lead to many different options within those paths that just in the API tree. And a lot of them were redundant and things like that, right? So, and they would be different if you were using TensorFlow maybe in Python than if you were using the API structure may be different in TensorFlow if you were using it for JavaScript. Whereas now, TensorFlow 2.0, now there's less than 300 different paths. So you can see that they've cut at that depth level 1, they've cut the amount of options in half, removed a lot of redundancy, and made it a lot easier to navigate. If you want to do something specific in TensorFlow, it's a lot easier to search out the path to just call maybe that specific function. And there's consistency and compatibility across different programming languages, and that's done through the introduction of these TensorFlow machine learning projects. So if there's something like TensorFlow, I think statistics is an example of one that you want to focus on, there's a path there. Or TensorFlow data, there's a path to do so. And it's a lot more organized and clear as far as if you want to search for something, where to do so. And finally, flexibility. So there's two different ways to program within TensorFlow. And what we're seeing here that is a highlight in TensorFlow 2.0 is the improvement of imperative or subclassing in development. So you can take non-TensorFlow Python code. It's a lot more easy to integrate, and you can have objects that include TensorFlow code, and it's a lot easier to go through when you're in Python to use both TensorFlow and non-TensorFlow code and get more of that. A big reference that they had in this work is kind of make TensorFlow kind of more similar to that experience that you get from NumPy, that it doesn't seem like you're stepping out of Python and into something else to do code. You're just kind of running it within Python, and you're getting that similar experience that a lot of developers are familiar with. So let's get into the IBM Cloud and see how you can use TensorFlow 2.0 and IBM together. Here, you can see Watson Studio, which is our data science platform for the IBM Cloud. This is the welcome screen that you'll see in our work here, and Watson Studio is defined in projects. So I already have a project developed here that utilizes TensorFlow 2. So I'll take you through some of the things that I've been doing if I just refresh some of my notebooks here. First, we're going to take a look at something very standard. If you've worked with TensorFlow before, we'll look at a development and how to an example of a model in TensorFlow 1. So I'm starting my notebook now. And you can see this first chunk of code. I am just importing TensorFlow. I'm going to be, at this last line here, printing out the version of TensorFlow that I'm using. Should be something that looks a little bit familiar, right? We're seeing TensorFlow 1. Then it's just a matter of downloading some data here. I'm using an MNIST data set. which is some handwritten digits, and I'll build a model to recognize those digits. So again, I was mentioning in those slides that a placeholder is something that's very common in TensorFlow 1. So I'm creating those now so TensorFlow knows how to build out a graph so that it can build that graph and then execute that graph. Build out the rest of the network and then just start training it. So what happens here as I'm training is, or what we can see that is kind of bothersome about TensorFlow 1 is if I get into training, here you can see I have 3 different layers within a network, and I have 64 nodes within each of these layers. Let's say I made a mistake and I don't want 64 nodes in maybe these first 2 layers. I want to change that. I can just stop my execution and hopefully, change the number of layers. Here you can see I'm changing them from within this layer. I'm changing them from 64 to 32, something that's very common in development of neural networks, to just play around with the number of nodes that you're using within each layer, see which one will give you the best result. I can't do so in TensorFlow 1 because we have something, TensorFlow is doing something that's pushing all of its variables into like a global namespace, and it's never really doing any garbage collection of any of my variables. So I'm trying to just reuse the same variables, just change a characteristic of them, but they were never really deleted. So it's throwing me an error saying that this variable already exists. So there are a couple of things like that, and a couple of things like building out and running a session. Here you can see another hallmark TensorFlow session here that we're trying to get rid of in TensorFlow 1. And I'll show a number of different ways in which you can train a model here in a different notebook utilizing TensorFlow 2. So we're going to be bringing in that same sort of model, that same data set, but we'll see some of the slight changes that you have to do to both install TensorFlow 2 and then get it to run and take advantage of some of those new characteristics. Okay, so here I have to install TensorFlow, so I'm going to be upgrading it to a particular version here, the one that just I think came out yesterday. Maybe it was their newest version of their, as far as I know, their newest version of their TensorFlow 2.0, and that is their beta 1 version. So I have to do some unique things to get it installed in an environment like Watson Studio, where I have this ignore installed flag here, and I'm uninstalling and reinstalling NumPy to kind of force it to update the version of NumPy in Watson Studio. So if you have any questions about what I'm doing here, particularly just to get TensorFlow 2.0 installed on Watson Studio, or if you're trying to do so yourself and struggling to do so, you can definitely let me know. I'm on the Call for Code Slack channel, and I'd be happy to happy to help if you're struggling. But we'll see here with these 3 commands that I'll be able to update the version of TensorFlow in Watson Studio into this new beta version of TensorFlow 2.0. Before I do so, I'm uninstalling NumPy. I had it at version 1.13.3. I'm installing it as version 1.16.4, and then you can see I'll begin to download and collect TensorFlow 2.0. Same thing we saw in the previous notebook, but now I'm printing out that version, and you can see the difference here. All right, so now I'm working with TensorFlow 2.0, but I still do the same thing from a data standpoint, just bringing in that MNIST data set and doing a little bit of pre-processing to get it into a format that my neural network is comfortable with. I said that eager execution is the default method of execution for TensorFlow 2.0. I want to run this same, if I want to run this same code that I was running in TensorFlow 1, I have to disable it because I'm not running an eager execution here. I'm doing that classic TensorFlow 1 style of building out placeholders, building out a graph, and then executing that graph. So I'll go ahead just to show how you can run the exact same code that you had in TensorFlow 1 and TensorFlow 2. I'll need to disable eager execution to do so. And then I wanted to pull down and download an example. I have that hosted on my GitHub and a link here to this TensorFlow code here to be able to train this network. And TensorFlow 2 comes with the utility to automatically convert old code into TensorFlow 2.0 code. So I can do so by just calling TensorFlow upgrade version 2. And then I let it know which file to upgrade and what to call its output. So I'm just taking a file called TensorFlow1.py Python and outputting it into a Python file called TensorFlow 2. And this upgrade utility will give me a log of all the things that it's changed in order for me to be able to get this to run. And you can take a look at that information in depth. And then also we can see here what it actually did. So if I print this out, and compare it to what we have here, a lot of the things that I'm seeing that are different, or it's just going through a different API tree to get to this compatibility section of TensorFlow 2 to point it to old, the old API tree in version 1, and then you can see a lot of it remains very much the same. But I can go ahead and copy and paste this and run it in TensorFlow 2, and it should work just fine. Here you can see it's training just as before. It's going to be a number of different, I think I have it for a number of different sessions. So we can go ahead and maybe just stop this execution so I can get on it to show some other ways that you can train in TensorFlow 2 that I think are a better use of its advantages than what you're seeing here, just upgrading old code. I want to get TensorFlow back to eager execution, as that's the default method of TensorFlow 2, but you can see kind of once you get started, you can't really change this version of execution, but that's no problem. I can just quickly restart the kernel and get running. All right, if I restart my kernel, I can still see that I'm in TensorFlow 2.0, which is great. I'm going to reload that data one more time, get that MNIST data set, and then be able to go and use Keras. So this is the same model that we've seen, only now it is in TensorFlow's new default standard high-level API, which is tf.keras. So this is TensorFlow's own implementation of Keras's reference framework. And you can see I'm just building out the same model here, the same number of layers, and now running it instead of just in TensorFlow and TensorFlow with Keras. And this is what I'm seeing if I want to do eager execution, right? I'm just building out this model and then training it right away. So you can see in this block of code, there's no reference to creating or running a session. It's just building out the model and then running the model. We're almost done here. You can see I'm only going through 5 training examples this time. As far as I think in previous examples, I was going through maybe like, I think maybe like 40 or 50. So we can let this run, and then I can show you the final example that I wanted to show, which highlights a new component of TensorFlow 2 called autograph. So you define, you tell TensorFlow 2.0 that you want to use autograph by denoting this at tf.function. And that will bring you into, we were saying in eager execution, there isn't that stage where TensorFlow is translating code and building out and optimizing a computational graph. By denoting it as this at TensorFlow.function, you can let TensorFlow know that that's something that you would like to do. And then you will be able to see, I think, you end up getting a lot more performant code doing the same thing, but wrapping it in the TensorFlow function. And what's great is you can do this for both TensorFlow code and just regular Python code too. And it will still build out a computational graph for non-TensorFlow Python code and optimize it for you and run it very quickly. So you'll see that this model here just finished training, and you can compare that with the difference in how long it takes this block of code that I have running autograph to run. So you can see it takes it a little bit of time to get started up front just to build out that computational graph. But then once I do, it goes through, since it's been optimized, since it's been translated into a higher programming or a faster programming language than Python, it goes through and trains quite fast. So that is autograph in TensorFlow 2, and then that is TensorFlow 2.0 in Watson Studios. So I hope that if this is something that you want to try, I am looking to go to this tab here. You can download the notebooks that I referenced today at this link here. There is a TensorFlow 2 repository that walks through and has all the notebooks that I've shown today and how you can try out TensorFlow 2.0 for yourself within Watson Studio. If you have any questions, I'll be on the Call for Code Slack if you're struggling at all or have any questions about these two and how to use them together. And if you're interested in IBM and TensorFlow and how they can be discussed together, and you're in the Bay Area, next Thursday there will be a TensorFlow meetup sponsored by the IBM data science community. We'll be discussing the two in tandem. I'm really looking forward to that. So that could be of interest if TensorFlow and IBM and how they work together are of interest to you. But thank you for your interest in Call for Code. As I mentioned at the top of the hour, I hope that we can really help some people here that are in adverse situations and do so with technology. So thank you for listening.
All right, hello folks. My name is Daniel Crook. I'm the Chief Technology Officer for Call for Code and the IBM Code and Response Initiative. So today I'm going to talk about the 2019 competition. This is the second year that we've been doing Call for Code. I'll talk about what's different this time versus last year's competition. Talk a little bit of actually some of the results from last year, some of the winners, what we've been doing with them to make sure their applications are put in place where they're needed most. I'll go over the rules, the judging, and how you can actually take part. So last week you may have seen with Upcar and Lisa, they took you through some of the coder activities, kind of how you can get involved in the challenge, but I'll cover some of that too if you missed it. And I'll also go over some best practices. So what we learned last year around the best applications that came out, what they did right. So hopefully all this will give you the tools you need to start building applications, kind of understanding how you participate in the competition and how you can do very well in it. All right, so first up, you may have heard two names already, right? Code and response and call for code. So I'll talk about how they relate to each other so you don't get confused. So code and response is a new initiative from IBM. And the goal for Code and Response is to be the overall program that implements the winning solutions from competitions like Call for Code. So again, we'll have a 2019 Call for Code competition. And just like with the 2018 competition, we're going to help the winners bring their solutions to life. So Code and Response is the way we do that. And Call for Code is one of the competitions underneath that support framework. And a new one also that came out earlier this year is our partnership with the Clinton Global Initiative. In particular, our commitment to train 10,000 university students on cloud data, AI, blockchain technology, and use that in the context of addressing natural disaster, preparedness, relief, and response. So those are the constellations, right? So the innovation comes out of the Call for Code competitions and the Clinton Global Initiative University events, and they all get supported within the IBM Code and Response Initiative. There's a few other things underneath Code and Response, such as the IBM Volunteers Program, our partnerships with like the American Red Cross, as well as our Corporate Service Corps program, which is going to be changing a bit this year. So if you want to learn about Code and Response, kind of the longer term program, it's got a URL on our developer site too, which is developer.ibm.com/code and response. You can leave out slashes, it'll go right there too. So check out that. And for both Code and Response and Call for Code, they're inspired again this year by natural disaster preparedness, response, and recovery. And just like last year, we've seen a trend growing that natural disasters are affecting everybody around the world. And they seem to be growing based on various factors, including changes in policy of public and private companies, changes from climate change, changes from types of planning activities, response activities. And so they continue to present a pretty large problem. So we want to make sure that we are doing the most we can as developers who now have this amazing power to build applications that can be deployed instantly, a new mobile application, a new web application, and also end users of those applications being able to share information. So we as developers can take our skills, bring those to people, and help try to solve some of these problems. So again, this year and probably into 2020, 2021, 22, there's still going to be a core focus around natural disasters, even though the challenge itself may be slightly changed from year to year. And in particular, this year, we are building again for Call for Code on building natural disaster mitigation applications. But what we're also trying to do is add a little bit more of an emphasis on health and well-being. So how do you help vulnerable communities? How do you get food and supplies in an area before they're needed? How do you guarantee access to clean water and healthy food? How do you understand how to improve the health and well-being of communities so they're more resilient to natural disasters? So I'll go over some of the ways that folks can do that. And I see this particular slide is a little bit goofy. Hold on a second. Let me see if I can fix that. All right, well, I'll just do it from here. We're going to do it live here. So Call for Code last year, so you understand kind of the outcomes from there, where it really had a tremendous reach. We hit 156 nations, so that's actual states, that's states within countries, places like Puerto Rico, part of the United States, but distinct identity. So we reached a huge amount of participation from around the world. Every continent, I think there was even one, maybe someone was joking, but they registered from one of the research locations in Antarctica. So it's kind of fun to see that. But these folks were inspired to create applications. Not all of them submitted applications for the main Call for Code competition, but they created applications. They were inspired to go try things out. And we, in addition to that single global competition, we had lots of satellite events last year, and we'll continue to do that this year. So for example, we'll have one in Fremont again on May 4th. We've got something planned for the UN later this spring in Geneva, as well as at least 10 universities and large corporations will all have their own hacks. And these satellite events are where you can kind of work on your idea in a 1 or 2 day period and bring those into the main competition. So again, just like last year, we're casting a wide net. We hope lots of folks participate from lots of different organizations, academic, enterprise, you name it. And just like last year, we are putting together a 5-point prize structure. So to attract and inspire applications that are really going to make a difference. So again, there's a cash prize this year, $200,000 for the main winner, as well as runner-up prizes. There's a physical award. You get actually a trophy, just like the folks from Project Owl did last year in the award ceremony. There's an introduction to mentorship to help you build your application, get feedback on it. Last year, that was through venture capital introduction. We're going to be doing something a little bit different, but similar this year. We'll have support from the Linux Foundation once again. So as your winning solution transitions from having won the prize to actually going into production, what we want to do is make sure there's a vibrant community built around it, which is what we're doing with OWL right now too. And finally, through Code and Response next year, the solution will be implemented on the ground, just as we did with Project Owl. So let me get into what we've done with the winner from last year. So, because Project Owl won the grand prize last year, they had an opportunity to engage a team of 5 IBM experts to go help them build out the user interface, improve and harden the software. They had a dashboard, for example, for end users to specify their needs and first responders to see those needs, as well as hardware to help them build out their mesh network solution. And in addition to that, they got consultation on marketing, branding. So we gave them a full support structure from IBM. And we did that in partnership as well with public and private organizations called implementation partners in Puerto Rico. So ITDRC, the Information Technology Disaster Resource Center, they're an NGO of tech volunteers. They helped us out in Puerto Rico to do some testing of the OWL solution. Engine 4, which is the hotspot of innovation in Puerto Rico. It's got lots of great connections between public and private, as well as educating students, educating developers, serving as a co-working space. And that place actually has an amazing story in that it was the single place in the western suburb of Bayamon that had power after Hurricane Maria. So it became kind of a community center, and therefore they've got really good firsthand experience on how you restore connectivity, what sort of things are needed, and the scope of the problem that affected Puerto Rico in 2017. We also did some testing with the University of Puerto Rico at the Rio Piedras campus in San Juan. We spoke with the Chief Innovation Officer and Information Officer. She's one and the same person this year. And we spoke to countless other groups, partners like Johnson & Johnson, AT&T FirstNet, folks that went through the storm, that have employees on the island. And they all helped us refine what Project Owl had built and make sure that it really applied in the context of Puerto Rico. So if you do want to check out more of the 2018 winner, they've got a GitHub organization, github.com/project-owl. There's a few repos in there. There's one for the hardware connection if you're interested in IoT side. There's for the software, the dashboard. There's one for their web application and some other testing tools as well. So if you get involved there, you can join the Slack community that they have and meet some of the other people on the team that have been helping them out, as well as those IBM volunteers that have been helping them improve the solution. So we do hope that to engage with them throughout 2018 as part of Code and Response to make sure that they can build a solid production application out of this. So very great to see kind of the full end-to-end of Call for Code 18 coming through here as we kick off 2019. So yeah, just a little more on what we did in Puerto Rico with them. So if you are the winner in 2019, this is the model we will follow as part of that Code and Response support. We spent 2 weeks on the ground in Puerto Rico working with the partners. For example, I mentioned AT&T FirstNet, the University of Puerto Rico. We met the governor of Puerto Rico, Ricardo Rosselló, demonstrated the solution for him, got some feedback from lots of other hackers on the ground in Puerto Rico, experts who were there, able to help us choose the locations for testing, learn about the local context, and in particular, learn about the areas that were most ill-served by response, I'd say, in terms of the ones that got connectivity, network connectivity back in 9 months rather than almost immediately. And that's where we really see the Project Owl solution finding their niche, is in reestablishing network connectivity for people to express their needs in a place where just a 1% network is going to be good enough, not a full 100% network to stream Netflix, but just enough to get some information over a mesh network. So very exciting 2 weeks down there. We led up to that with 12 weeks of working through Slack, introducing the IBMers to the Project Owl team so that we were able to hit the ground running and continue to give them recommendations after that 2-week deployment. If there's actually an AP News article, unfortunately I didn't link it from here, that talks a bit about the testing and the outcomes we did. So if you go to callforcode.org, there's a press section on there. You can find the link. It was syndicated out to over 50 different publications. So just look for Puerto Rico attracts tech developers. That should get the article for you. But a great time to test and iterate. And we did end up doing 4 large-scale tests, determining the straight line distance that a mesh network can use as a relay to get back to one known good location from the farthest possible point. We did some urban testing. There's a lot of concrete in Puerto Rico that affects radio waves, ensuring that in dense areas the solution worked there. We tweaked the power versus the bandwidth to make sure it covered the right area. We checked at different topographies, different elevations by the coast, in the mountains, to ensure that there's a broad base of information the OWL team could use to improve what they built. So very, very exciting to bring the 2018 winner to that environment. The other teams too from 2018, they've all been working on their ideas as well. So Project Lolly, they have been creating an application. The team has created a startup building a community in France right now. They've been working with IBM over there. They've also been working with Sigfox. So the lead developer just came back from an internship with them. Sigfox is an IoT network. So that's the wildfire solution that came out of Project Lolly that's being iterated on. Project Lantern is working on their mesh solution. They'll be doing some testing in the New York area in the June timeframe. PD3R, they are building out their artificial intelligence application, something that helps identify whether a damaged building can be retrofitted, that is kind of strengthened, or has to be torn down and rebuilt completely, all to help them get people back into their homes after a disaster as soon as possible. We're working with them. That's an organization called Build Change, buildchange.org. And UAN, a network from the Agricultural Bank in China. They're still working on their visual recognition access to capital solution. So all of these folks are on GitHub, and they'll soon be linked from the Linux Foundation. We'll have a dedicated page for them. But they're all hard at work iterating. And you can hear more about the Iris solution actually in this upcoming documentary. There's a trailer off of the Code and Response website. You can kind of check some of the background of what the folks have been doing over there and what inspired their application last year, and maybe how that inspired your application for this year. Okay, so the specifics on Call for Code 2019, again, very similar to last year in terms of the prize structure that I mentioned, as well as the scope. The scope is slightly different in that it's looking for applications that do have that health and well-being aspect covered. But anything is eligible, right? If you're creating an awesome application that does something related to natural disasters, it's definitely something that's going to be considered by the judges. But I think most applications, because we're aiming to save lives by mitigating natural disasters, there's going to be some human component, and that will fall over to health as well. So think broadly when you're building your solution and see if you can frame it in terms of being something that improves the health and well-being of communities. We're building up an ecosystem as well. If you're a developer, obviously you want to take part in this competition, or a designer, or an entrepreneur, or an subject matter expert, you definitely want that. Those people participating in the competition. But also, if your organization wants to be involved, we've got lots of different ways for that to happen. So callforcode.org, the global initiative, is setting up partnerships for supporters, essentially a logo exchange, an option to write a blog post, do a tech talk interview to share the expertise or share the APIs that come out of the ecosystem. And we've got our UN and Red Cross partners again this year as well. So the competition officially opened February 12th at the IBM Think event. That's when we announced Code and Response as well as Call for Code 2019. But we opened it up for submissions last week. So there's a larger push, and you'll see it over the weekend too. We're going to be sharing through a cause flash some more information about Call for Code with the communities that go beyond developers. So it goes into celebrities, it goes into eminent technologists, it goes into universities. So you'll see a lot of activity this Sunday on World Health Day as we raise awareness of why this is important and trying to get everybody involved with it. So that's April 7th. As I mentioned, we've got an event going on in Fremont, California again this year, as well as close to, I think, 500 events around the world where folks can learn the technology to take part between now and July. And the close of submissions happens July 29th. So you have 4 months about to start your application, start building on it, creating a roadmap for where you're going to take it after July 29th, all things that'll help the judges learn how mature your application is, the problems it's solving, and where you intend to go with it. And it all culminates this year, again in October, on the the UN Day for Disaster Risk Reduction, which is October 13th, I believe. It's a Saturday. Again, it's usually the second Saturday in October. October 13th is what it says in here. So that's when the awards will be given out. Okay, so I'll pop over to show you kind of a demo of how one goes through participating, but at a high level, there's 4 steps to it. It's simplified from last year. So there's just one place. Well, there's 2 places. Callforcode.org, again, is the global initiative. It's the competition for this year. So it's got the challenge scope and it's got the submission platform, because that's what's going to be used for judging. But IBM has also provided a community where folks can engage with experts and use technology to build their initial starts of their application, the foundations for it, and use that. So the very first thing you should do if you want to take part in 2019 is go to the Call for Code challenge community. You'll find the button either on callforcode.org or this developer.ibm.com/callforcode page. Just fill out the form. That'll get you in the IBM Coder community, where you'll learn about the challenge. You'll see the tech areas, the disaster areas, the healthcare content we have, so that you can start exploring, introduce yourself, work with the technology. You'll find team members to work with as well. Actually, I see that that should be step 3, and then go step 4. Done on the fly. So 4 steps. So you join the community. That'll get you entered in the competition. You'll start playing with the technology. You'll meet some teammates, again, up to 5 people, 1 to 5 people on a team. And then you can submit your code after you're done. And this year, too, we're encouraging folks to submit early. And if they want to iterate on the application, maybe change some metadata about it, the team name, the team members, they can always resubmit. So we want folks to understand from step 1 to step 4, essentially the resources they have, and what's expected, and where they are in the competition. Okay, as I mentioned, as you enter the competition, start to work with the IBM Cloud technology. Again, we've got the 6 tech areas. If you entered last year, you may be familiar. We're focusing on data science, Jupyter notebooks, analytics, predictive analytics, things like that. Artificial intelligence using bots, natural language translations to interpret data on the fly. blockchain for tracking resources, financial networks, supply chains, traffic and weather, so you can understand what sort of conditions might precipitate before a storm. Internet of Things, so just like the Project Owl solution, using the Watson IoT platform with small, low power, low capacity devices. Machine learning, and visual recognition, understanding patterns, and seeing if there's a way that you can automatically categorize or pair for an event or respond to an event. And those are also cross-sectioned against six disaster areas. So earthquakes and tsunamis, hurricanes and typhoons, wildfires, volcanoes, floods and storm surges, and extreme weather. So you'll find tech talks, so videos, code patterns, blogs, tutorials, and those are constantly being updated and refreshed. So look out for more information there. And you'll get to that through through the IBM Coder community challenges too. So when you registered, when you joined the challenge community, you'll be taken through some ways to play with these technologies to get familiar with them. But you can use any code pattern you like on the IBM Cloud. We've got close to 200 of them. All of them can be used. You don't have to limit yourself to what's in these categories. Build something amazing and use these tools. There's also some stuff for the new focus. So healthcare, again, videos, insight, priorities. Take a look at it all. And if you have any suggestions for it, enter it in the coder community. If you found a cool data set, feel free to share that with other competitors. And hopefully that'll help you build a team of like-minded folks that want to work on the same applications you do. Okay, so now that you've joined the challenge, kind of explored the technology, you're getting ready to kind of put your idea into action. Let's talk a little bit how they're going to be judged. So the judging criteria are the same as last year, and they're equally weighted. And they cover how mature your application is. We understand in 4 months you're not going to be able to build a full-scale production system, but we do like to see an application that's solving a real-world problem that can be applied in the local context, but also possibly deployed elsewhere in the world. So if you're building an application for hurricanes in Puerto Rico, it may be something that somebody in the Philippines can use for a typhoon as well. So thinking about the global impact of what you've built, and basically how transferable it is also in how quickly someone else may be able to stand it up themselves from an open source repository, how they can understand it, and how they might be able to take part in it right away and understand it. Effectiveness and efficiency. So we don't want techno-solutionism, that meaning that you just apply technology for the sake of technology. We want to see applications that are informed by real-world problems. And if they can refer to some existing research or an article or some statistics that show the scope of the problem they're trying to solve and why it's important to solve it, all of that, making that clear to the judges is very important, is to show that, hey, I didn't just build this application because I thought mobile apps are cool and drones are awesome, but that I built something that really makes sense. And how easily does it solve that problem, right? Is it something that can be put to work, right, by an end user, by a very busy first responder? So is it something that's going to contribute to solving a problem without adding undue complexity? Okay, and that kind of feeds into the design and usability. So how does somebody actually consume this thing? If they themselves have to go set up an entire blockchain network, that's expensive, that takes time, that takes partnerships. An end user is not going to do that. But you as a developer might have resources to kind of figure that out, solve how that can be done. And in the case of a mobile application, you want to make something ideally integrated with an application they may already have, rather than building a brand new application. So think about plugins, think about leveraging things that are APIs and things that are already on the mobile device. No one's going to go download an application immediately after the storm, especially if they're trying to conserve battery and network connectivity. So think about how they can use a solution within a set of constraints. Again, preparedness is a different story, but so think about think about your end user. How are they going to use this? When are they going to use it? What can you expect them to be able to have? Excuse me. And finally, creativity and innovation. So how are you solving a brand new problem that's been overlooked Are you bringing a 10 times better solution to the problem? Are you making sure that it's really adding some magnitude of value that maybe hadn't been thought about before? People were too close to the problem, got too myopic about the potential solutions, that they didn't see this brand new approach that's enabled by technology that could make a difference. So all that stuff is going to come together. We do want to see as mature the application as it can be. And there's no answer to, well, how mature does it have to be, because you're competing against others in the competition. So we don't know how you are going to do relative to them. But consider these 4 areas and you'll do well. I will say last year's competitors, Project Owl edged out the others because it had a good mix of all these criteria covered. Some of the applications may have been stronger in certain areas, the runners up, but they didn't have the full breadth that Project Owl brought. So I would say, try to cover all these, consider them, address them. And if you haven't, if there's some gaps at submission time, so when the deadline comes July 29th, make it clear in your roadmap. Say, hey, listen, this is where we are, but here's my plan. If I won this competition and had access to winning prizes, I could build out my solution to do this. So that's all completely fair, and it's something the judges really want to see. Okay, so let's look at some of the key rules then. So to be eligible for the prizes, and as with last year, the winning 5 teams will have to Apache 2 open source their solution, and they will have to build brand new code as part of this, with the kind of exception or the understanding that applications aren't built in a vacuum, right? So we don't expect you to build an email parser, right? Something that's going to send SMS messages. We expect you're going to use libraries, things that are available to everybody else in the competition, APIs, standards, open source libraries, NPM modules. Those are all okay to reference from your application. And your application may be glue in many ways, right, between some existing things. But ensure that there's enough originality in there that the judge can say, yes, this is a brand new application. It's clean IP that came from you for this competition. Sure, it's got its dependencies listed, but it can be stood up by anybody and it can solve the problem. So the flip side of that is it can't be an existing commercial product that you created. It can't be something that someone else can't reproduce without undue effort. That's the spirit of the competition, and that's what the judges will hold you to. So as with last year as well, you can participate alone or with up to 5 participants. As you're working through the competition, you may kind of work on different ideas and be on one team and then decide to go work on another team. Just make sure at the end of the competition that you are only listed as being as part of one team, and you're submitting one application. So when it comes down to it, make sure that you're only part of that one team. All participants must be 18 in order to compete, and you can't be part of multiple submissions, part of that same idea. And as with last year, IBM is providing cloud data AI technology. And as you join the challenge community, you've got a special promotion of being able to have $200 credit, good for 6 months after you convert your Lite account to a paid account with a credit card. But last year's winners, for the top 5, they did it with all free services. So we do encourage you to take advantage of those offers, use some of the cooler cloud technologies out there. But as long as you're using something free or not from the IBM Cloud Catalog, it is eligible. And that means you can also build multi-cloud solutions. We know that that's a reality for most applications these days. A mobile application will involve, for example, often like a toolkit for using APIs on the device for rendering things. We also know that Google Maps is very popular, integration with SendGrid for sending emails. All those things can be part of your solution. But as long as you've got one application, one IBM service in there, or it's hosted on the IBM cloud, or it's running on mainframe for those who are not doing network connected public cloud applications, Check the participation agreement, which I'll get to in a bit, but it'll describe the complete rules. Okay, and one thing we're doing differently this year is instead of waiting towards the end of the competition for folks to have a look at the submission form, I know for me, whenever I'm doing writing an abstract for a conference or building, some submission, I like to just draft things out in a text file. Make sure I don't lose anything on the web. If my session time's out, or the form fields change, or some cache, get post and all that stuff when you accidentally click submit and now you lost what you created. I write everything out in a text file in a Word document. I kind of suggest that you do that too. But the submission form, so it is now available. You don't have to log in to use it this year. You don't have to log in to see it. So I encourage you to go check out callforcode.org/submit. You'll also find that link through the coder community as one of the challenges to explore this. Open up the type form. Take a look at the fields, what it's asking for. It's got the link to the participation agreement as well. And just see what the text field limits are, kind of what the judges are looking for. You've also got them listed there in the callforcode.org FAQ and on that page. So in summary, that's submission names, your team name, or just a short name for what you and your colleagues are building. Short description, what's your pitch in 10 words or less. A long description, so think about 1 page of printed text that describes, what the problem is, what you've built, why it matters. Include a solution roadmap, so where you are in your kind of vision for what you built, and a link to GitHub or source code repo. So there are field links in those other fields, but if you have additional diagrams, additional documentation, you've got unlimited space in GitHub or GitLab or Box, wherever you decide to put your actual code for the submission. So take advantage of that. Do have great documentation, another best practice, and just keep in mind that you can put additional videos there, put additional information that's going to help the judges. In the form itself, you'll want to give a 3-minute overview video, and talk about the IBM software you've used or services or systems, and you can list your teammates too. So one thing that's different also for the submission form is that it's stateless this year. So you don't have to log in to see it, you don't have to log in to submit anything, but it also means you can't come back and edit your submission. What you'll do instead is, if you submitted something under your email address as the submitter, as the team lead, if you want to improve anything, if you want to change the roadmap, if you want to change the description, obviously you can iterate on GitHub as much as you want before the end of the competition. As if you want to come back and resubmit something, just fill out the form again. We'll take the latest submission from your email address and use that as your final submission before July 29th. So, feel free to get something in there. Another thing that we're talking about is some regional competitions. You'll hear some announcements around those. So the earlier submits, you may actually have more of an option to win some additional prizes, but more on that in the future. Okay, so let me hop over to talking about some of the tips that came out of what we learned last year. Some of this stuff, we also had a seminar at the end of a webinar at the end of last year's, right before submissions. So these best practices are consistent with those last year too, but also informed by some of the judging we did last year. So as you saw in the judging criteria, we're looking for applications that'll make a real difference, that are practical, that can be put to use, that can be deployed in a reasonably short-term time frame. But it's all about quality. It's about solving the right solution, considering the end user, and making sure it's a brand new, innovative approach to a long-term problem. So there's lots of materials out there. We'll continue to do the tech interviews. We've done more on the IBM Developer YouTube channel, interviews with experts from FEMA, from medical sciences, from lots of different areas. Go check out the tech talks from last year, from this year. Understand the problem, understand what they're really seeing as a core thing that's affecting how they do their jobs as a natural disaster expert. The UNISDR Sendai framework has got some excellent information in there, how people in the private sector, how individuals, how communities can prepare for and respond to disasters, and look for other pieces of research in the field. I really encourage you to not think of the technology first, understand the problem, understand the approaches people have taken in the past, and see, where you see any missing links, and focus your application on those. Because when you do your submission, you also want to reference some of these studies to ground your application for the judges in why you built it. Okay. And related to that, tip number 2 is don't reinvent the wheel. Right? We are looking for brand new applications, things that haven't existed before, and there's plenty of room for innovation. But a lot of the value of that innovation is in understanding the layout, the ecosystem, the landscape of what's been done before, and the tools that are already doing very well in the field right now that may just have gaps in them. So explore, if you have an idea that you're going to create an amazing drone-based visual recognition solution, keep in mind that many people have gone down that path before, and there's certainly room for improvement in terms of better drones, better visual recognition, better algorithms. But look at what's been out there, build on those solutions, plug into them, make them better. Right? Don't reinvent the wheel. And there's a whole bunch of standards out there. There's a whole bunch of APIs, libraries that are looking for technology solutions. And in fact, we spoke to the folks from Oasis, a standards organization, a few weeks ago. They've been working on an XML standard for message sharing between first responders, communities, basically those alerts, those Amber alerts that go out. That's based on the EDXL format. And that's been adopted in some communities, but not around the world. So they're looking to drive adoption of these tested, implemented solutions. And they're looking, for example, for new ways for people to consume them. So building a mobile app that has an XML parser or maybe a JSON version of this format. Think about that. Look at the great stuff that's already been out there that people have spent years of their life working on. Find out how you can bring that to your community, or how you can share that and bring that into the latest cloud technology. Okay, tip 3. So one of the things we realized last year is we asked folks to, they document their solution in the submission. They provide a link to a source code repository, but it's quite hard to match the promise maybe that's made in the demo video with what they've described in their roadmap versus what's actually in the source code repository. And it was a little frustrating for judges last year to see an awesome demo video, a great team name, a great mission statement, a great description, and then you go to the repo, and it's just like boilerplate GitHub, where you got to drill into a whole bunch of folders, and then you're like, that's where it is. Me as a very technical judge, I knew how to navigate and find that stuff and kind of understand how complete it was. But other folks, they may not be able to kind of make sense of that GitHub repository and see that from the same point of view, and therefore may have rated the application lower, even though it was awesome, but it just wasn't evident how mature it was and whether it was something real. So do your best to obviously build a great application, but don't neglect the README files. Don't neglect all that information. Your GitHub repository is really going to be obviously being the most important thing as being the code itself, but also the key source where people can learn about the application and see what's there, see how mature it is. It's the meat behind the sizzle. And again, with this year, we expect that people are going to patch their repositories after the submission date, but there can't be significant changes in those repos after the submission deadline. If there's continuous integration, Travis build fixes that have to happen, judges will understand that, but your application functionally has to be complete by the deadline. Okay, so going back to the video, again, take advantage of using kind of your GitHub repository as the most complete thing you have, but the thing you're going to need that most judges, technical or not, and again, this year we're going to have technical folks, developer advocates from IBM, SMEs from the Red Cross, SMEs from the UN, SMEs from lots of different areas. The thing that's going to appeal to every judge to set your application, your submission apart from everybody else is an awesome 3-minute video. It doesn't need to be, full production grade movie trailer. That's cool. We saw one of those last year, which was awesome. It was a little suspicious because it looked like it was, built before the competition, but it wasn't. That was quite amazing. But really, use that time to show what you're doing, show the maturity of what you built, and show where you plan to go with this. What's your long game for this thing? And do it in as compelling a way as possible. Tell the story. And you can provide a longer form of that video, again, linked from your GitHub repo, but focus on this really being the pitch that goes to the judges. Every judge will look at this, even if they can't make sense of every last detail of your GitHub repository. Spend some good time here. And being that you'll provide links to a GitHub repository or a YouTube video in your submission, make sure that the judges can see them. We had a couple submissions last year that sounded great. What was in the submission itself was great, but the Vimeo video maybe required a password that wasn't given, or the YouTube link was marked as private, or the GitHub repository was again private. The easiest thing to do is flip the public bit after the deadline. So if you want to keep your kind of solution to yourself until others, so no one else can submit the same thing by copying you, just wait till the deadline and then make it all public right after, because the judges won't start judging on August 1st. There will be kind of a little bit of time. So as soon as the deadline passes, turn everything public, and then the judges can have a look at everything, and no one else can build their application using your idea in the competition. There is a private, service ID for the Call for Code judges. You can invite that as an outside collaborator too. It makes things a little more difficult, so I do just recommend publish it, make sure it's Apache 2 license, make sure there's no passwords on it, and that's gonna make it the easiest for the judges to figure out what you've built. Okay, so let me now go over to working on the cutting through the end user experience. So we'll see how this goes. And in the meantime, Mike, did we get any questions in the chat? Oh, yeah, I see it now. Yeah, I got it pulled up the other way. Cool. Okay. All right, then I shall go over to developer.ibm.com/call for code. So this is a great place to start. Submissions are open, actually, and you don't need that banner anymore. I'm gonna close that. So what you'll find when you get here is you'll be able to enter the competition by joining the challenge community. That'll get you all the accounts you need. That'll get you access to the code. That'll get you into the community. So that's mainly what you're gonna do on this page. You can also explore some other stuff before you get to that point, though. I put together a blog post, kind of the welcome letter. It covers some of the stuff I just talked about. You can check that out. You can go over to the callforcode.org community. So callforcode.org, since that's the global initiative, that's the competition, that site is the canonical source for the rules and the judging platform. So again, you can join the challenge community from there as well. And you'll find, you'll learn about the scope, what we're looking for. You'll learn about the prizes in more detail, some of the tools that are available to you right now, the schedule at a high level, and some of the technologies that you can start to use for your application. Again, rules and judging. And as we get the eminent judges listed here, those will show up as well. So you kind of know the background of the people that are going to be looking at your code. So, so yeah, you can join the challenge community there. You can join it here. It's the same form. And you can kind of take a look at some of the other stuff. So if you want to catch up on what the winners were doing from last year, you can check out Project Owl. listen to where they're at and where they're looking for folks to help them out in implementing their solution. And you can also find the link to the resources here, the code patterns for particular technology areas. And if you're new to the IBM Cloud, basic link to the docs, and you can see the other code patterns. So you don't have to limit yourself to what's here, but these are ones that are pretty well used, pretty pretty popular, and pretty well used last year, as well as in some of the applications we've seen built this year. So that's the resources. That's the health information. We've got a page for those areas too. So the health and well-being emphasis. There's areas: food and water safety, supply distribution, disease epidemics, health records access, mental health, and vulnerable populations. So these are all inspire you to kind of build your application in the context of health and well-being. Okay, so and you can also find a link to the events. So there may be local regional competitions happening in your area. There may be meetups on IBM technology. You can find those here as well. And I believe we do have about 500 planned over the next 4 months. So I'm sure you will find something. And we have some virtual hackathons that will be announced as well. So if you are that one person that I mentioned in Antarctica, don't worry. If your satellite uplink can handle the stream, we've got stuff for you. Okay, so yeah, the first thing you should do, join that challenge community. I will try to create one here right now. Let's see, let's go with demo at cloud.com. Let's see. What shall I call this? Okay, good. Okay, you can see. Okay, good. Let's create an account. Oh boy, the captchas. Yep, I got them all. Okay, check. Validate that. I've got it in another window over here. All right. That's wrong. 1 second. Okay, just activated my account. Okay. Okay. Oops. Okay, and once I do that, I should be into my IBM Cloud Coder community. Should drop me in there. Oops. Actually, I can just use the URL there. This is the link to the Coder community it will send me into, but I've closed that window by accident. So after I sign in, join the community, it's going to bring me to the Coder community. And within the Coder community, I'll have a set of experiences to go through. So they will help me understand the challenge, check out the welcome videos, learn about the challenge scope, and then go through a couple of oops. Oops. Okay. T's and C's. Okay, let me configure my profile. So this is the coder community, the first time you join here. Full name. I'm not going to show my email address. Should do that so I don't confuse myself. I am a developer. Now it's called Cloud Dragons. Okay, good. Okay, so I've got my profile updated, and I am now in the Call for Code experience. So as you go through the coder program, what you do is you kind of work your way through. It's a guided roadmap, basically, for taking part in Call for Code. And as you go through the experiences, which are composed of these individual numbered challenges, you'll earn credits, coder credits. Those can be used down the road. Right now, you can't cash them in for anything just yet, but we've got some plans for them. But basically, work your way through the numbered challenges. Many of them are pretty simple. All you got to do is watch a video, kind of learn about, read a blog post, and then take some action. And once you complete it with them, they drop under the completed challenges. So you can see whenever there's new stuff that's released. So we have weekly new content and maybe a new blog post, a new API from a partner. Those will all show up in the experience. And introduce yourself on the forums, get familiar with the IBM Cloud, work on one of the code patterns. So working through how to build a chatbot using the IBM Cloud. You can go through the steps on those. And wrapping it up is when you've gone through this, you've met your teammates on the forums. Once you've kind of worked your way through the challenges, met some folks, introduced yourself, interacted, asked some questions, and you're finally ready to submit your application. If we look at this final preparation one. Go over to the submission form. And this is where you can explore what you'll need to take part. So everybody on the team has to accept the participation agreement to be eligible, but only the team lead needs to go ahead and submit. Go take a look at the form. Take a look at the David Clark Cause privacy policy. Call for Code is owned by David Clark Cause. IBM is the founding partner with them. But they own the privacy policy, so go take a look at that. Take a look at the participation agreement, which has details as well from the rules and eligibility. And then you can start to enter your team name. Disasters. This is amazing. It will have a 10x impact on food security. I'll just grab some of this here. Sometimes I just use the lipsum.com, has some fun dummy text generator, but this is the one page of content. Roadmap, you can just upload a file there. Let's see if I have something I can do. Ecosystem, let's see. Let's use this calendar. Okay, I've got a file on there. Oops. Okay. Put a YouTube video in there. Okay. Okay. And I have affinity for the All-in Islands. Dragons. And I don't have any teammates, but if I wanted to, I'd enter them there. And that's all you got to do is submit. And again, if I wanted to update that, I can go ahead and do it. Again, we don't expect everybody to submit up front, but feel free to explore that, kind of work through what you've submitted. And that's it. You are entered in the competition. So we're coming to the top of the hour here. I hope that was helpful, that was valuable. Does anybody have any questions in the chat or anything? Otherwise, you can always find me on Twitter. The Twitter handles should be up on the screen. You can mention me, and I can give you any information you may need after this. I'm in the IBM Coder forums as well, so look for me there. And good luck.
Hi, everybody. My name is Derek Ta. I'm a developer advocate here at IBM. And today I have John Wallachy with us. Hey, John, how are you?
Hi, Derek. Nice to meet you. And hello, everyone.
So we're going to go through a couple things today here to give you some content around building apps with IoT and Node-RED. So as always, we're going to talk a little bit about Call for Code, which, as many of you probably know, Call for Code is an initiative where we want to do what we can to help recover from or mitigate, prevent natural disasters utilizing technology. And so this year, the challenge is open for submissions until July 29th. So if you have already started working on stuff, great. If you haven't, there's still plenty of time to get started on that. Again, July 29th is the deadline for that. Some other things that will help you along your path. We've been going through and building blog posts that talk about each of the content areas in Call for Code that'll kind of help you along your journey. So in that next tab, John, there's one example that I have on building Call for Code apps with IoT and Node-RED. So you can find that on the Call for Code blog on developer.ibm.com. I think we can drop a link in the live stream for you as well. But this is just one of a couple that we've written. So I've written one on IoT and Node-RED, written one on AI. I have one coming up next week on traffic and weather. There's a blockchain one out there. There should be one going out today, I believe, on machine learning. And then we're going to talk a little more about data science 2 weeks from now. So,
wow, you've been pretty busy, Derek.
Yeah, it's been a push to get this stuff out. You know, we want to get the best content we can out there for Call for Code. So lots of stuff there, lots of good information. Every one of these little blog post references are code patterns or tutorials. This one, John, happens to have a highlight in here, which is we're going to go through some of that today as well. So you'll see that there's a lot of resources in there that you can get started with. If there's something that does come up that you have questions on or whatnot, you're welcome to tweet me if you'd like. You can find me on Twitter, Derek TA. Feel free to send me a message if you're noticing something's off, or if you notice that there's an issue or something, please reach out to me. I'm happy to help. So I want to talk about some of the main points on that blog post John had up there. So
Sure.
Just to highlight a couple things, there's a video there as well if you'd like to check that out. Again, yours truly, John's right there to kind of talk a little bit about some of the IoT things going on in that article. But one of the cool code patterns that I highlighted here was one on using Onion devices with Node-RED on the IBM cloud. So this was something that John wrote. And John, I want to give you just, brief amount of time to kind of talk about this. If you had any, useful things about the Onion Omega devices, and if there's anything you could share around that.
Sure. So I build IoT solutions with a whole variety of devices from lots of different partners that IBM works with to bring data from the device up to the IBM cloud for analytics. And so we've got great partnerships. And one of them is with the Onion team, and they produce a $5 Linux computer, which is one of my favorite things because anytime I can skip lunch and buy a $5 Linux computer, that's awesome. So what was fun about their device, it's basically a very small little chip there, and it's about the size of a postage stamp, and you can add an SD card or flash it right to, it runs Linux, and it's got sufficient horsepower to actually, it's a MIPS-based processor, so you can install a derivative of OpenWRT. And what's really cool about it, Derek, is you can run Node-RED on a device about that size. I added an OLED screen, so I can put little messages out there. It's got a USB port, so you can connect devices to it. And it's a full Linux computer, which is so awesome.
That's really cool, yeah.
And then, of course, you can hang sensors onto it as well, which is what the whole point of our story today is.
Right. So it's kind of like a Pi, but smaller, right? Raspberry Pi?
Yes, smaller than a Raspberry Pi, for sure. And cheaper.
Yeah, which that's awesome to be able to get your hands on some tech like that and play around with it, and it's not too expensive. That's great. Thanks, John. And then also, you'll see, so on this page, there's a link for the IoT code patterns as well. So if you want to check that out, there's some more code patterns centered around IoT. So that should be helpful for anyone that wants to start or wants to do more with IoT and their call for code solutions. I'm going to go through one last set of resources here before I turn things over to John. We have our code and response page that you can see here, and under the resources link, there's our list of technologies there. And if you go under Internet of Things, there's again some even more code patterns, which you would also find from where we just highlighted in that article. But additionally to that is also some tutorials, some blogs, videos, depending whatever type of media you like and you want to use to learn best. So right under Internet of Things there, you can find even more resources to get started with this. I know some people like to watch videos, helps them learn things a little bit better. So there's videos on here as well. So plenty of stuff to learn, plenty of things that can be adapted towards call for code. So
Derek, you're going to be back to talk not just about IoT, but with others over the next couple of weeks to talk about AI and machine learning, data science and blockchain. You have a schedule for that, I heard.
Yeah, so we'll be doing those over the next I think now 4 weeks. So we'll be working on that. I think the next one up, I think it's blockchain. So we'll have some people there for that. So stay tuned for that. Blockchain is always a really interesting topic, and we have some good people that are going to be helping us with that live stream. So
did I hear that you have Oliver Rodriguez on?
Yeah, we should have Oliver.
Awesome.
Yeah.
If you get a chance to join the NOLA live stream, you're going to have a great time with Oliver. So encourage everyone to join next week with Oliver.
Oliver's definitely the blockchain guy to talk to, that's for sure.
I learned so much about the blockchain from him.
And actually, I highlighted him in my Call for Code blog post about it. You know, I happened to be working an event with him, and I said, you know, I could write a generic thing about Call for Code and or blockchain. But I said, Oliver, you know, give me a quote. Tell me give me in your words, you know, what you see blockchain is. So I got a nice quote from him. So who better than him to have him on? So we should have him coming up here.
All right, let's talk about IoT.
Yeah, absolutely. Go ahead, John. Take it.
All right. So I think you invited me to really talk today about a tutorial which I had penned last couple of months ago about how to create an IoT platform starter application in the IBM cloud. So if you're building a call for code solution that uses any type of IoT and you want to get data up to Watson IoT platform, maybe you want to create and use a Node-RED flow in the IBM cloud. You want to store that sensor data in a time series cloud and database in the IBM cloud. Maybe you want to store the data and then bring it over to Watson Studio to do some analytics in a Jupyter Notebook and some Spark ML learning. But you'll need to start with a Internet of Things platform starter. And so what I did is I wrote a tutorial, which we're going to talk about today. And so the learning objectives will be to walk through the tutorial, show you how that's done. But then, because that's sort of just read and click, I thought we would then turn it over to actually take a real device. And in this case, I picked a Texas Instruments sensor tag. It's just a Bluetooth sensor tag, but it's got a bunch of cool sensors. I'll talk about that. And this Bluetooth device with a bunch of light, temperature, humidity, accelerometer, gyroscope, compass, sensors is going to talk to my phone. And I'll share my phone on the screen, and we'll see some data going from the sensor to the phone, and then up to IBM Cloud over Wi-Fi. And we're going to capture that data in Node-RED. Actually, we're going to first send it to Watson IoT platform. We'll see it arrive there, both in Quick Start and as a registered device. So we'll walk through those steps. And then we're going to jump into Node-RED, and we're going to build some cool little Node-RED flows. Those of you, I'll introduce Node-RED if you're not yet familiar with it. We'll go through an introduction there. We're going to build some charts. And because once your data is arriving, you want to do some real-time alerts. And so I thought we would.
You want to see it visualized well instead of just seeing raw data.
Right. Yeah. So after a while, you don't really find the insights in just a raw stream of data. What you really want to do is graph the data in a set of charts. And we'll live build that all. And I'll actually have prior examples, but they're in my head. I'm going to craft it all with you today, Derek.
Wonderful.
We'll see how that goes. If I get all my typos out of the way, we'll do great. We're going to spend about 2 hours, maybe less. But what we're going to do after that, I figured, okay, every IoT demo needs a blinky light. So it was insufficient just to send data to the IBM cloud and graph it in Node-RED and see some real-time sensing. I decided now, of course, I've got lots of blinky lights. And so there's a remote control light bulb. It's called a LifeX light bulb, but I usually have it plugged in my ceiling, but you can't see it. So I kind of plugged it in over here, and later on we'll pull that out. It's really bright, so I'll probably turn it to its side. And we're gonna, as we shake our sensor tag, if it hits some accelerometer extremes, we're going to, from the IBM cloud, detect that alert and send the command down through the Wi-Fi to this particular light bulb, and it's going to flash red and on and off.
That's really cool.
So, but let's tie it back to call for code, because imagine you had a bunch of sensors in your project, maybe your health and wellness, maybe you're trying to track an emergency vehicle, or maybe there's tornadoes coming, and you've tied your data stream to the weather company, and you're following the severe weather alerts for your zip code, and you want to inform the citizens. Well, maybe if you're deaf, you can't hear the tornado siren to head to your bunker. Maybe you want to have a flashing light. And so, that's pretty easy examples of a sensor, accelerometer, temperature, gyroscope, and blinky lights. So that's what we're going to build.
Yeah. Great use case.
Should we jump in, Derek?
Yeah, absolutely.
All right, let's do it, man. All right, so here we go. So we're going to, and I'll scroll and jump to tabs, and we'll do it kind of together. So the first thing we're going to do is we're going to create ourselves a Watson Internet of Things starter application. And of course, you want to get yourself an IBM Cloud account. So if you don't yet have one of those, you want to go to cloud.ibm.com/register. Those of you that already have an account, go to /login. And I've already logged in, but you want to jump over to the catalog. And we've got so many services in the catalog that you want to take advantage of. Some of them are microservices. Some of them are infrastructure. If you want to build your own security products, all of our Kubernetes and IBM Container Service, really cool there. You stand up and instantiate storage, Cloud Object Store. All of our analytics tools are here in the IBM Cloud catalog. We've got tons of databases, but we also have some Internet of Things and security. And so we're going to jump. So it's microservices that you need to wire together. That's sort of what cloud native is about. But there's some patterns to it, Derek, that really make it easy to put together, and they kind of go together. You want Cloud Foundry to manage your Node server plus Node-RED plus an Internet of Things and some Cloud Object Storage and a Watson IoT instance, right? That's a pretty common pattern that most projects would need. Heck, we did it for you, right? So we kind of put it together in a starter kit, right? Why make it hard? Yes, you can go and create every one of those microservices and with API keys, string them together. Nice thing about Cloud Foundry is you can bind them sort of under the covers. There's all command line CLIs to this, but we can just do it from the IBM Cloud catalog. And so what we're going to do is we're going to go into the starter kits, and this is so awesome because if you need an example, we probably have got you 75% of the way there. Java, a bunch of different Java instances, mobile, Node, microservice, with Express.js. Maybe you want to build a web app, Python, bunch of Python examples, a bunch of Swift examples, a whole set of chatbot examples, NLU and visual recognition, and Node-RED. But we're not just going to do Node-RED. We're actually going to do up top here is the Internet of Things starter kit. So let's jump there, and you'll notice that I'm going to log in, and so I'm going to there. I just got myself a new set of tokens. Cool. And so you have to give your app a name, and I thought we would call this call for code 2019. How about that? IoT.
That works.
All right. And we're going to put that, I've got a bunch of different spaces. So we're going to put that in my dev space. And we've got a whole variety of availability zones. So I'm going to just create it in Dallas. Now we've got a whole bunch of availability zones, 60 different data centers around the world. If you need to comply with GDPR or data privacy, maybe you don't want your data to leave your local country, you can go to one of our data centers and set it up so that it's local to your region.
Yeah, that's awesome.
In my case, I'm just going to use Dallas. And so here it is that just got created. And it's going to, so now what's happening in the background is a server somewhere in Dallas is now taking a set of build packs and putting together a Node.js web server. It's going to add a bunch of NPM packages for Node-RED. And it's also creating an instance of the Internet of Things platform for us. And we're going to sort of jump through both. Now, the cool thing about, so while this is running, I'm going to take you over to the dashboard, because dashboard is sort of where you manage all of your services in the IBM cloud. And so it's right from the top left hamburger. You're going to go to the dashboard. And now I have, as an IBM developer advocate, quite a few more services than you. If you just create an IBM Cloud Lite account, super fun, right? Free, don't even give us a credit card,
Nope.
But you've got a limited amount of services and never expires. So there's no time limit. It's just the APIs are kind of capped. But I've built a whole bunch. I've built about 26 of them, and a bunch of services that kind of go wire together into them. Watson AI, which I haven't talked about yet. So all of the Watson AI services are here as well in the IBM Cloud catalog. Speech to text, text to speech, language translation, all of the emotion APIs. So maybe you want to build something with tone analyzer or natural language understanding or personality insights. Those are really cool call for code, especially about the health and well-being. So if you want to use some of those AI services in your project, really awesome too. In addition to those, we have the chatbot service. And what else did I miss here? Oh, visual recognition.
Yeah.
Awesome. I do so many. So I've got all my drones. Derek, I'm a drone guy.
Oh, yeah.
So I tied my drone to Watson Visual Recognition, trained it to look for survivors on rooftops in a flooding environment.
Wow.
Detecting rescue boats in the flood zone and directing where the rescue boat is and where the rooftop survivors are, and making sure that the rescue boat gets there in time.
You're giving out some really great ideas for call for code. Jeez.
Yeah, matter of fact, I have a tutorial on that. So if you need to build a survivors on rooftops, do something really fun with that one.
That's really cool.
All right, so that was a little digression over to the dashboard where you can manage. So here's all of our availability zones, sort of our status and maintenance page. and then you can launch into all of your apps here. And so I got a lot of them, but I'm actually building the one here. Where'd it go, Derek?
I think it was, yeah, your resources thing. I think we navigated.
Yes.
Okay, 2019.
There it is.
Yep.
So it's this one, right? Call
Yep.
for Code 2019.
Yep.
Go take a look, see if it's started yet.
But it's nice that it does all of this for you, as far as, you know, instead of having to wire multiple things together, it's spinning up all of this stuff when you create it so that it's all, you know, ready to go. Save some time, save some setup.
Yeah, you saw I gave it a name and I clicked the button.
Yep.
Right?
Very
That's
easy.
all I've done so far. But what I've got now is I've got a cloud database to store the Node-RED flows and any of my sensor data if I want to. I've got myself an IoT instance over in Watson IoT platform. And you'll notice it's free. And I've in the free tier, I have 256. I have only one instance. Now, if we were to build an internet scale application that handles millions of hits, you would want to put multiple instances and failover in multiple regions, which we're really good at. We're happy to help you do that. But I'm just sending a little bit of sensor data, so I'm not going to, try to create multiple zones here.
One instance will be sufficient for that, yeah.
Totally fine. Totally fine. All right, so it's up and running, and so the next thing I want to do is kind of do a little digression, because we want to go create a device and start sending some data up to the cloud, right?
Right.
All right, so let's so what I'm going to do next is, so here's what I'm going to do, guys. I'm going to share my phone. I have a little app called Screencast, and I'll show you that in a second here. So I just turned on Screencast. I'm going to go create myself a new tab, and so that's my phone. And so we're going to say, okay, that's great. What we really want to do is we want to go to the very center of my screen is a sensor tag. See the little sensor tag icon?
Yep.
In the middle? All right, so now let's talk about our sensor tag. I'm going to turn it on. Put a new battery in it yesterday, so hopefully it'll be good. So it's got a little tiny blinky light, tells me that it's running. And so now it's Bluetooth, low energy. I'm going to go click on that. It's now doing a scan. I actually have a few of them in my house. So we're going to just click on the one in the first one there, the Bluetooth one. And you can see I can scroll a little bit, and I've got some accelerometer data, so I'm going to shake it, and we see that we're just getting data from Bluetooth over to my phone. All right, so ooh, that was fun. So you can kind of see it big, right? If I wanted to, I can kind of scroll up there. So we're going to be able to send the motion accelerometer data, gyroscope data, all the light sensors. We're going to send a light luminosity to the cloud. What else can we do? Load some firmware. Not so interesting. Oh, so humidity and ambient temperature. So we're gonna send that up to the cloud, and so at the very top there's this push to cloud, right? So I'm gonna try not to move my phone too much. So I'm gonna hit advanced here, and instead of using IoT platform, we're just gonna start with quick start, because heck, I don't have yet really configured anything. Let's just send some data to quick start. And I don't want to type this stupid long number, so I'm going to give it a name, call for code. All right, let's try that.
Great.
And I'm going to hit save. All right, so hopefully if I go, see, it keeps overriding that. We got to remember that number, Derek.
Okay.
All right, here, I got to write it down. I think I wrote it down somewhere else, but I'll write it down again.
I'll jot it down just in case.
06AA05. Okay. All right. So we're just gonna. It's just the MAC address of the sensor here.
Okay.
Let's go flip the push to cloud button, and you see a little blink there. So every second now we're going to send data up to the IBM cloud. Let's go see that it's arriving, and quick start. So let's jump up to quick start.
While you're getting there, John, what does one of these devices cost?
Oh man, these are like 15, 20 bucks.
Okay, another low cost sensor that you can play with.
Yep.
Awesome. Okay.
Yeah, now I got to type that number in, Derek. Did you memorize it?
Yeah. Oh yeah, definitely. Right up here. 20. Yep. I think that's it.
All right, cool. All right, so it's connected. There we go. And so here's my data in the cloud. Let's go pick one that's sort of interesting. The gyroscope one, Gyroscope X. We can kind of shake it. And so we're plotting Gyroscope X. So I didn't do anything except, so now my now I know my device is connected and sending data up to IBM Cloud. Now, truly unsecure. If you all want to go and type this number into Quick Start, Internet of Things, you could watch my sensor data too. It's a great example, not something you would put your heart pacemaker on, right?
Right.
Probably not a good idea. So you want to use security, and that's our next step. So before we go to actually secure the device, let's go over to our app. Remember, we built that app, and we're going to actually pull some data, this data from Quick Start over into IoT platform.
I just want to note, I can't believe how quick and easy that was to just set up a sensor, read the data from it, and get it talking to the cloud. That's incredible.
Yeah, TI did a really nice job. For which TI and many others, I've got so many fun partnerships with Particle, ST Microelectronics. I've been doing some new things with Sony. Of course, the Raspberry Pi Foundation. I've got more Raspberry Pis in my house than I know what to do with. I got all sorts of stuff. Every ESP8266s. All right, so we're going to go through the Internet of Things starter questions here. Now, this is Derek. I got this totally wrong yesterday. Forgot my password while I was talking. We're going to call it Call for Code, and we're going to give it a password. How about something I can tell everyone?
I'll memorize this too, just in case.
All right. Let's hopefully it was Call for Code. I don't know what it was. Call for Code 2019.
Okay. Memorize it. Up here. Got it.
Caps, not caps. I'll tell you later. All right. So hopefully we can remember that. So now we've notice up in the URL here, we're at Call for Code 2019 IoT mybluemix.net, and Node-RED is running on the web server there. It's Node.js app. This is where I got to type that in, Derek.
Right.
Call for Code.
You got that part.
See if this works here. Oh man. See? I told you I wasn't going to be able to do it.
But it's always the live demos, John.
Derek. Call for Code 2019. Yeah. Me.
Did you have a cap in there somewhere or in the password?
I had caps all over the place.
But better secure than insecure, though, right? So
yeah. I'm convinced I should just pick really weak passwords. Damn it, Derek.
I'm baffled here, John.
I told you I can't. This had all this. Holy crap!
Well, the other thing is too that I always notice when we set these up, we don't have a confirmed password. So if you goofed it when you typed it the first time, you don't get the opportunity to fix it with the confirmed password. So
yeah, that's why I typed it twice.
Yeah.
Code 2019, right?
Yeah.
Holy crap! All right, so I failed, Derek. I totally failed the test. I told you I was going to fail the test. Man. You sure?
Bear with us, everyone. We're having fun.
Oh yeah, no, it's fun. Call for Code. There's totally a way around it.
Mm-hmm. Trying to think, do I know that off the top of my head? Worst case, you could always
Yeah.
redeploy it, I suppose, right? We could redeploy
Yeah,
it.
I could go delete it right out of the
Yeah.
passphrase here.
Yeah, you might have to.
Oh man.
You could just deploy a new instance, set it up again, I guess, if we want to do that, right? Unless you know the workaround to.
Yeah, let's try. Runtime. You think so? I don't think I did. Call as a username.
Hey. So the
That was
password
great.
was right all along. Thank
Fun.
you, whoever caught that. Appreciate that.
That was good. Thanks for watching. Hey, I'm stealing my passwords even. So, because I can't remember them, you might as well. Let's get started. All right. So, Derek, the first flow, we're going to get back on track really fast.
All right.
First flow is sort of a sample. We're not going to use it, so just to get it out of the way, I'm going to delete that. And we're going to rename this tab to be called Quick Start. So because we're really just going to kind of show the Quick Start story. And so the first thing we're going to do is going to, in our palette. Oh, has anyone seen Node-RED before? So Node-RED, visual programming technique. You have a palette of nodes over on the left. You're going to select from the palette, drag it out to your, this is called a flow. And so here's a debug. So we're going to wire the two things together. On the other side, we've got information about the node, like how to get, configure it. And in this case, the debug is going to actually print out some information, sort of the printf for Node-RED. And then when we're ready, we're going to hit the deploy button. But we have to do a little.
Sorry, just to point out, yeah, Node-RED is a great low-code environment, but some people might think low code might be, low power. But this is a very powerful platform. So pretty much whatever you want to do, it's easier. And the thing that's great about it is it's great for developers that want to prototype something quickly. But what I've also found from doing hackathons, and John, probably you've seen this as well, that this is also a great tool for people that maybe aren't quite as technical, or maybe designers or even business users that want to contribute to an application or a program or an idea. And it's a little easier and a little it's more simple to comprehend, dragging the stuff over, and you can see the literal connections between these nodes and kind of understand how they work.
That's right. Yeah. So very powerful way to get started and build some pretty amazing apps. Yep. All right. So remember, we're going to use Quick Start instead of the bound services. We're going to get to the bound services as our next little journey. But let's go see that data. Hopefully, we're still sending some data. Although the device sometimes goes to sleep. So I just hit deploy, and oh, here we go. Every second, I'm getting compass, gyroscope, temperature, ambient temp, air pressure, barometric pressure there. So this is kind of interesting, but really hard, Derek. I'd have to scroll and watch each little JSON object here. Mm-hmm. We want to build a chart next, right?
Right.
But before we go build some charts, I'm going to jump over to Watson IoT platform, and we're going to actually configure this device. Okay.
Perfect.
As a secure device. All right. So let's go back to our little journey here, and not that one, not that one. There we go. And remember, we have some connections, and we created ourselves a call for code 2019 IOTF service. So let's just launch into that. Now, there's a landing page in IBM Cloud for the IoT platform, but then there's a whole UI portal for this. So we're going to jump over. We're going to hit the launch button now, and we're going to And we're going to remember this number up in the upper right corner here. That's going to be important for us. That's our org name is NQYYX8.
Got that too, John.
Yeah, I just wrote it down. But so quick little tour of IoT platform. You can create little dashboards here. We're going to create some devices. You can assign membership to others in IoT platform. We can obviously do app integration here. You can manage the access to the devices. So you could do all sorts of device management, get some usage metrics, create some real-time rules and events. That's kind of clever. We're going to talk a little bit about security and TLS. And but let's go start with devices here. And before we can add a device, we have to kind of build a device type. And I'm going to go click on add a device type. And I'm going to call this one call for code. And so we'll hit the next button and say done. So now we've got ourselves a device type just for today. I could have called it, Texas Instruments or ST Micro or Particle. And we're going to go create ourselves an actual instance of that. So in our case, let's go and name this one sensor tag 1. Sensor tag 1. And we'll say next. And we can skip over all the little introduction. Now, this is an important one here too, Derek. We need to remember this one.
Okay.
I earlier typed call for code 2019.
Mm-hmm.
Right? Yep.
Yep, that looks good.
Now I only get one chance at this one.
All right.
It's done.
We'll
right,
remember this together, John.
Yeah, we're going to need to memorize this number. I'm going to go paste that somewhere else because we're going to come back to that maybe if we mess it up. And now before we can, so remember I haven't done a lot yet, and this app on my phone doesn't have, I can't put a key in, but I can go down to security, and I'll make this bigger for everyone because it's sort of really small.
Yeah, that's good. Yep.
There's a set of security settings here. So we're going to edit our security policies. Now, we wanted to do TLS with token authentication. We also could do client certificates, server certificates. And so we're going to go and set that up this way. And so that our device from the app can talk. Now, if you were to build a real solution, you want to go generate keys. We've got some instructions on how to generate keys. And that way your device knows it's talking to the IBM Cloud, and the IBM Cloud knows it's talking to a trusted device. All right, so now let's go up to devices. And there's our device. We haven't sent any data yet. So let's go flip over here. Remember let's go unlock my phone for a second. And hopefully you got that now. Wake up, buddy. Maybe I have to go screencast again.
The live demo gods are getting you today, John.
No, it's fine. This is all just click through the silly things. Try again. Start broadcasting. That's my phone. There it is.
There we go.
All right. So it just took a second to resync. All right. So now we just launched the sensor tag again, but now we're going to enter into that advanced tab. Now, instead of quick start, we're going to use IoT platform. And so in this case, we have to fill in all the details here, Derek. It's sometimes a pain here. So this is use auth token is our user ID. And our password that we typed in earlier is call for code 2019.
Yep.
And other things we need to do is we're going to change quick start here. We're going to put in that number NQYYX8. And now we have to go and build ourselves. We're actually going to use MQTT to send the data, Derek. So our phone is going to send MQTT data up to IoT platform.
Okay, cool.
All right. So the trick here is to go D colon, and then our org name, which was NQYYX8, and then a colon, and our device was call for code. Or actually, our device type was call for code, and then our it was sensor tag 1, right?
Yes.
All right, so let's go check my typing, call for code. Yeah, that looks good.
That looked good.
All right, cool. All right, so I'm going to say next. And oops, here, let's go save. And let's go turn that on. Ah, man. So when I type it wrong, Derek, it crashes.
It looked right to me, but
was that?
I thought you typed everything right.
Yeah, it did something wrong. Use token auth.
Oh. Good catch.
Oh, hopefully that was an easy one. Last night I had lots of typos. All right, hit save. All right, cool. Now we're going to go turn that on. Yeah, nice.
Hey,
now we're sending data. All right. So now let's jump back over to Watson IoT platform, not Quick Start. See how we're disconnected from Quick Start now? We want to go over to our IoT platform here. And no, not this one. That was the old one. There's our new one here. No, not that one either.
Too many tabs. I always fall victim to that.
There is too many tabs. This is the one I'm looking for. Hey, so it's
coming through. Yeah.
So we should be getting new devices. I can go and shake it, right? And I should be getting new sensor readings. So now we see that the data is arriving in IoT platform. We see it's connected. And so that's kind of good. You can go and check all the logs. There's our authentication log. Yeah, see where I failed over here?
It's nice that it logs it so you can at least see if something's going on or figure out what issues you're having. Yeah, that's great.
Yeah, from a security perspective, it matters a lot. So now let's go fix up our Node-RED flows because we want to do some other interesting things with it, right? We've gone through our tutorial already. And now we've connected a device. Now we're going to jump over to Node-RED and start to do some other things. So let's go call this one charts. So we're going to build some charts. And so now we're going to go grab ourselves another IoT instance. But in this case, we're not going to use Quick Start anymore. We're going to use the bound service. The Bluemix IoT platform knows which one it's talking to. And we want to track sensor tag 1.
Yep.
Right.
And just a quick note for anyone watching this that Bluemix used to be what we called IBM Cloud. So if you're looking at this and wondering what Bluemix is, we're transitioning all that over to IBM Cloud. So synonymous, but we're trying to phase out all the Bluemix stuff. But in case you're wondering what that is.
Right. And so now this time we're getting that same data, but it's using secure TLS up to IBM Cloud as a registered device with a token, and we're now this is still not interesting. We're going to get to build a chart in a moment, but at least we see that data is arriving, and I can shake it, and it's coming every second. So we'll let that run in the background. Now we want to add some charts. Remember, Node-REDs, you've got this big palette here. There's over 2,000 nodes that you can add to the palette now, Derek. Huge. It's awesome. Yeah. It's an open source project governed by Linux Foundation and the OpenJS Foundation, the Node-RED project led by an IBMer, Nick O'Leary. He's working on Node-RED 1.0. and soon imminent release of Node-RED 1.0 beta. So
Wow.
you hear here soon first.
Awesome.
So we're on a pretty rapid path now to bringing Node-RED to 1.0 stability.
That's excellent.
We're going to add, and so if you're interested, jump up to flows.nodred.org, and here's 3,000 different nodes.
Wow. Almost anything you could ever really want to, create, really.
Oh yeah. So I remember that light bulb. I'm going to talk about the light bulb later. We're still not at the light bulb step. But yeah, so I bought this light bulb. It was like $30 somewhere at the flea market. And I said, awesome. And there's a node for it. And so we're going to actually later on, we're going to install the Node-RED contrib node lifex. And we'll get started with that. Okay?
There really is a node for everything, huh?
Totally. Actually, we're not going to use this one. We're going to use the other one. Anyway, there's another one for it. All right. So let's jump back to our Node-RED flow, which is over.
One more over. There you go.
And so we're going to go over to the manage palette. All right. So let's talk a little. So remember I'm going to flip tabs back to our service here. We created a service, and in IBM Cloud, we just go back to the dashboard and navigate that way. We created in the light tier, we get 256 memory. Right. And so we're going to try to get everything into 256, which was a little tight last night. I'm trying to do everything in 256 memory in the cloud. And so what I had to do, all right, a lot of tabs, is I had to go, before I can add Node-RED dashboard, I need to delete some stuff. And it actually doesn't really let me delete it here, Derek. So I need to make some space. We're going to get rid of some things here, so we can add Node-RED dashboard.
Okay.
Because we don't need all from our little demo today. We don't need everything. And the way we're going to do that is we're going to. It's nice to use the palette manager when you can, but in this case, we're going to use the tool chain. So we're going to go turn on the tool chain here. And so I'm going to go create myself a tool chain for continuous delivery tool chain for our little app. We'll generate a key, and so we can talk to it securely.
And it's nice. This is all handled on the back end. It's all multiple things being set up just as a one-click thing to handle your CD stuff, right?
Yeah. So right there, that one little click, I now have a delivery pipeline. I've got a Git repository, Git issues, and I can jump in and manipulate some code now. So underneath, remember it's a Node.js web server. Well, I'll make that bigger for you. So this is basically the Node.js web server. And we're going to go manipulate package JSON because remember I said there were some packages we didn't need and we need to add. Node-RED dashboard. So we're going to put that in edit mode. You know what we're going to do is we don't need Mongo, so we're going to free up some space there. We don't need OpenWhisk, so we'll get rid of OpenWhisk. We'll leave IoT platform, but we're going to get rid of some of these virtual devices. All right, that should be enough space here. And what we're going to do next is we're going to add 2 more packages to this. And what we need, I sort of did that over on the side here. So I need Node-RED dashboard. Just make sure I got the tabs right. That's good. Because we know tabs matter.
Absolutely.
All right, so we're adding Node-RED dashboard and the light bulb control thing. And you know what? Instead of Node 6, let's upgrade ourselves to Node 8 while we're here.
Now, if someone else wants to do this, is this the best way to do this, or can you do it from the Flow editor as well, or?
So you can do it from the editor if you've got enough space. But I found last night that I was right at the cusp there where it would start to work and then it would run out of memory.
Okay.
So let's commit some changes. And so now in the background, this is a good opportunity for us to talk about continuous delivery, because I'm now over here in my delivery pipeline. I want to go take a look at this. And you can see here, my last pass was just a couple of seconds ago. And now I'm doing a restage and a redeploy of my my application.
Just picks it all up automatically from the last Git commit, right?
Yeah, so it rereads the package JSON, and now it's grabbing some build packs. There's all Kibana behind this, and you can go look at the log files. And hopefully it's going. We know it's going.
That's pretty convenient. I mean, it's always good to set up a pipeline like that when you're working with, whether it's IoT stuff or Node-RED or whatever. Even if you're just using one of our starter kits to build like a web app or something, it's nice to have it, to be able to just have it do all the things for you, make the change. You don't have to fire anything off manually. You can just let it build and deploy for you.
Yep. All right, what do we got going on here?
It's thinking.
I did some of this from the command line before last night too. They just upgraded to use new passwords. It should be running here. There it goes.
Yep. Download everything.
So it's pulling in all the new build packs. Remember, I wanted to use the new Node.js build pack. We've got build packs for Python, Flask, and for Java, Liberty, PHP, and Go, Ruby, Swift. So all the build packs come in here.
While this is building and you're talking about languages, do you have a favorite language you like to write in? Like, what's your go-to if you're going to write something?
So I'm an embedded Linux guy for years and years. So for over 30 years ago, I was a C programmer. So it's still my go-to as a Linux kernel and embedded guy. Jeez. But today I write a lot of stuff in JavaScript in Node.js.
Okay, cool.
Just as cloud-based stuff.
Yeah, that seems to be one of the most convenient things to write in these days. So I know Swift is also getting to be big too, because you can write it, server side and on apps and stuff. So I didn't know you do much with Swift, or still more of a JS guy.
So I'm an Android guy, so I don't really. I have
right.
My iPad for iOS, and all my kids walk around with attached to their iPhones. But I mostly am an Android Studio Java programmer.
Okay.
Android Studio.
Yeah, cool.
So when I need to write a mobile app, it's usually in Android Studio and Java.
Back in the day, I used to do just some fun hobby stuff with Android, but just with IBM, it's just like, man, we use a lot of Mac stuff, so it's just like, yeah, I'll try an iPhone, and it just, I got used to it. Not quite as powerful as my Androids, but it works.
Yep.
Our build went through.
Yeah, it's taking some time here, but we can. So obviously, when it's busted, it's restarting. It's we could start to construct some of this while it's going. I don't know if it's going to be throwaway work. Let's see. So remember, I'm going to get a bunch of data, Derek, and I'm going to use a change node, and I want to in message dot payload. I'm not sure if it's going to let me do all this D, and we're going to use ambient temperature, ambient temp. and we're going to call that temp.
So the change node just reformats data that comes through.
Right. Yeah. So remember we got this big data structure over here of JSON object, and we're going to go grab particular readings because we want to split it out and send it to different charts now, right? So that's what we're going to do. And so let's just start to do that. We're also going to grab the humidity. So let's see if we can go grab humidity. All right, so it did restart. Hopefully it remembered my password. Cool.
Hey, there we go.
And now we're going to go grab payload.d humidity. And I'll wire that up. And let's go, and we're also going to look at the light sensor because it's got a cool little light sensor on it.
But just for those watching, you can use one change node for multiple ones of these. But John, you probably do this way, the same way I do, because it's easier to look at them individually and it's a little more visual, right?
Yeah, and matter of fact, what we're going to do really next is, so remember, I'm going to hit the deploy, and I'm going to show you over here. I might have to hit refresh. Yeah, I'm going to have to hit refresh. Over in our palette now, we've got our dashboard nodes. See our dashboard? And so what we're going to do is we're going to go grab a chart node, and we're actually going to do 3 different charts. That's sort of why I had to do them separate.
Okay.
And so in the first chart, we're going to send the temperature. In the second chart, we're going to send humidity, and then we're going to have a light sensor. So we're going to go create ourselves a new group, and we're going to call these sensors. Let's just call this. We're going to call it, instead of home, we're going to call it call for code. And it's going to be a dashboard. Cool. So now we've got a group, tab group called sensors, and we're going to make it a little bit bigger so that we see our little sensor data. And now we're going to add the chart. This first chart is going to be temperature. And then the second chart is going to be humidity. And it already knows to put it in that group. And in the third chart, we're going to call it light. Oops, light. And let's go deploy and see what this looks like, Derek. All right, so let's jump over. So here we have our dashboard. We've got humidity, light, and temperature. And let's just go put temperature on top. And let's go and see what we got. Oh, we're not sending any data yet because it turned off. But we have three charts here in a second. Let's go and turn. So I'm back to my phone, which I probably won't bother taking you all to.
No problem. So you got to get it get the sensor, talk to the phone, send those.
Yeah.
Data.
All I really did was flip the push to cloud.
Oh, okay.
All right. So now we're getting sensor readings every second or so, and we have it'll smooth out in a moment. All right, so now cool. We're getting sensor. We're showing sensor readings in the IBM cloud. So notice the scale was really tiny there. I could have adjusted the scale. All right, so now that was just humidity, light, and temperature. Let's go add. We want to add another group column, and we're going to put our what do we want to do? Oh, you know what we're going to do is, I know why it's zigzagging like that, because we're also getting another, I'll show you what the problem is. We're also getting, it keeps telling us the name.
Yeah. It's hard to catch them when they're moving on you.
Yeah, it's moving on me here fast. All right, well, there's a way to filter that.
Yep.
So we're going to go in here, and we only want status.
Now, is this specific to this sensor tag, or is this?
Yeah, no, it's in their little firmware.
Okay.
I think that's probably slowed it down a bunch now. Yeah, it comes too fast.
Yeah.
For me to, that one was data. I don't even want to try by. All I'm doing is sending the name of the device every couple of seconds, every second. Yeah, let's see if that smoothed it out or not. All right. We can put another filter in, but we're going to go add a couple of more nodes here. So we need to add a change node. And this one's going to be accelerometer data. I made this really tiny for everyone.
Sorry, you should still be able to see. It's all good.
Yeah, is it all good? I can fiddle with size if you need to. It's payload.d.excelx. And because, so now remember we want X, Y, and Z for accelerometer all in the same sort of chart here. We're going to actually set 3 different topics. Let's just go put that in my buffer, Control C, Control V, Control V. And we're going to change this next one to Y. So we get ourselves Y. All right, and now we're going to make this one Z. Cool. Now, let's go wire them together. Now, we don't want to send them to separate charts. We want to send that all to one chart, X, Y, and Z all to one chart, because charts can do, it's a multi-plot line. So we're going to wire them all to the same one, but they have different topics. So they're going to come in with accelerometer here. And so instead of, we're actually going to do is we're going to put it in a new group. And we're going to call this new group called motion, because we're going to have accelerometer, gyroscope, and compass. All right, let's go see what that looks like.
Could you make it just slightly bigger, maybe up to 100%? Because it's an
Yeah.
There we go.
It should be coming up here.
Boy, yep.
Yeah, remember I told you we were tight for memory? We're still tight for memory here. We're tight for memory. This was what was happening last night. I was trying to make space for it. All right, well, it sort of looks like this.
You got a backup. That's always good.
Yeah, of course I have a backup, Derek. When I can't spell, I have a backup. So here you can see I did the same thing. We're sort of building the same. Here's X, Y, and Z, accelerometer, gyroscope, and compass. And now, of course, I'm not getting data over here yet. But I had a new set of charts, right? A new set of charts, which we'll go and set up our stuff here. If this does come back to life. Oh, it came back to life. Okay, it's just catching up now.
Oh, there we go.
Yeah, it's just catching up. So now we have accelerometer data. I can. It crashed. It's just catching up. The other one didn't have all these. Didn't have as much trouble there. Maybe I was searching for.
That is, I mean, the point of it is it is working. So you're getting live
Oh, yeah,
data
yeah.
from that.
Pretty
so
cool.
That's pretty cool.
Right. Device event, sensor tag 1. All right, so now let's want to go bring the light bulb in, because we're getting about an hour. I want to light the light bulb and then wrap it up.
Sure.
All right. I think I'm a little too tight, Derek. It keeps crashing on me. I say we switch.
All right.
So what I'm going to do is so remember that light bulb? Let's go turn the light bulb on, and that's like crazy bright for you all.
Little bright, yeah.
Yeah, sorry. And I can toggle the power. I can turn it off, right, and turn it on. All right, so what's really happening is, so I'm running up an IBM cloud, and I'm sending a true on and off, and I've set myself up with a LifeX light bulb developer account. I got myself an API token, which you all can steal and blink my light in my house if you want to. If you can memorize that number. And now I'm sending data from the IBM cloud to the LifeX API down to my Wi-Fi connected light bulb. We screw it in. There's an app, you connect it to your Wi-Fi, and now I can remotely change colors on the light bulb. So I can kind of send it. That's I'm blinking green. I don't know if you can see it's green.
Hard to see the color, but definitely can see it blinking.
Yeah. Well, I also blinked it red.
Ooh, that's doing some cool stuff to your green screen.
It does. It's kind of strange, but I can blink it red. And now, so what we're going to do is we're going to wire. So when I shake the sensor tag and I get all accelerometer data, I wanted to be able to shake the sensor tag and flash the red light.
Before you do that, John, real quick. So just for those that aren't familiar, the things John clicked on, those are inject nodes. So you can send data to somewhere just by clicking on the little blue button there to inject a particular set of data, whether it's JSON data or some other type of payload or the string, whatever it is. That's how you send that data in Node-RED.
Right. All right. I'm just setting that up now. We're going to shake our little light here, and we're going to say save. Yeah, let's go show you what I got here. Let's go get a little bit bigger. Current flow. Oh. Deploy. We're going to turn on push to cloud here. So now I'm getting accelerometer data. And when I stop, it leaves the light bulb on now, right?
Mm-hmm.
And I could shake.
Wow, that's really cool. So that would be a great way. So like, like you said, earthquake, something like that going on, it can read that data and then show it visually to someone that may not be able to hear it audibly or something like that, right?
Right. Or, I've the life, I need one, like you put it on your what do they call it? The little lifeline on your necklace.
Yeah.
So if you have I've fallen, I can't get up.
Mm-hmm.
So you can put a sensor on something, or bridge or a person or a car. And if it's got accelerometer data or gyroscope, compass readings, you can. So in this case, it's Bluetooth to the phone, Wi-Fi to the IBM cloud, into Watson IoT platform, over to Node-RED, into my little. I extract the accelerometer data here, and then I have a threshold. If what I just did was 3 Gs or no more, it sends a command, this little flash to light, and I flash it red by calling another microservice over in another cloud someplace. And it then talks from IBM cloud to the LifeX cloud, down across the internet to my Wi-Fi, to the light bulb, blink red.
So while that sounds complicated, most of that stuff is set up just from just deploying it in IBM Cloud. Most of that's done for you is just, fill in API keys and configure a couple things, right? It's not terribly complicated to do something like this.
Not complicated at all. It's the power of microservices and cloud native.
That's really cool. I've not seen anyone do, link a sensor to a light bulb like that. So that's a really, really cool demo you showed there, Don.
So I got my wife and kids think I'm crazy because there's a lot of blinky lights in my house.
That's pretty neat. I mean, like you said, there's a lot of potential for turning something that's, something fun like that, where, if you want to, there's a million use cases for it. You want to track the objects that your cat knocks over, right? You can have the light blink for that. Or if you want to track something more important, like, earthquakes or other things, like, I mean, it's adaptable. And that's what's cool about it, is you're able to put something fun together like this and go, oh, while this was a fun project and something just, to learn the technology, you can see how adaptable that kind of stuff is to call for code.
Yep, that's right. So Derek, I wasn't able to watch the chat, this live stream, too much. I just jumped over. There were some Omega questions earlier.
Oh, sorry.
And let's see if I can. So the question is, can you put a camera on it? So the cool thing about both, I have got the original, the Omega 2 Plus and the Omega S Pro. Both of them have USB ports on their little dock. There's a USB port there. And if you get yourself an eyeball camera, I can't because I'm looking at it right now. Plug your Logitech or your eyeball camera in. You can capture video data, and then I've got a bunch of Derek. Have you seen my Twitter visual recognition nodes?
Oh yeah, that's really cool. I've shamelessly steal that from time to time to demo it, and it's always really, really good stuff to kind of show that stuff.
So you take an image and you pass it to Watson visual recognition, and you can, get back what Watson thinks it sees in the picture. So yeah, you could easily do a surveillance camera. Watson Studio allows you to train, so you can train on the mailman. My dog hates the UPS guy with the brown uniform, and the mailman with the blue uniform. He just goes crazy. But then when the guy gives him a treat, it's his best friend ever.
Right. Yeah, that's really cool. That's a pretty neat use case. I mean, like I said, I've demoed that before to kind of showcase that you've put together, and I find it to be pretty accurate too. Like, I mean, I've sent out a photo of my car before, and it'll come up and say, Watson thinks this is a floret red, sedan, and it's like, yeah, that's what I own. I have an Audi RS3 that's Catalunya red, but close enough, right? So it knows that it's a red car, 4 doors, and it has a whole confidence thing about, oh, this could be a rental car, because you don't know, it could fall in that category. It's a really, really cool way to kind of get information out of images.
Right. Yeah, so visual recognition is really powerful, and of course, Daniel Crook here would like us to do a water sensor, because he needs a litter box detector. So Daniel, buy me a 6-pack of beer, and we'll bring my water sensor up and a couple of Arduino boards, and you get yourself a litter box water sensor.
That'd be a fun live stream, right? I think that's an open invitation for us to come up to Daniel's house. That's what that sounds like.
Perfect. Love that. All right. So, Derek, should we wrap up with any call to actions? Maybe jump up and register for Call for Code?
Yeah, absolutely. So that was the last couple things I had here that I wanted to talk about. If you go to developer.ibm.com/call-for-code, that's where you can join the community and answer the call to join us at Call for Code. We'll drop that link in the chat for you. But take a look through this. Learn a little bit about the 2019 challenge. You can learn a little bit about what happened last year at the 2018 challenge as well. But it's definitely something we want to try to tap into the developer community to help us come up with some good technology-based solutions around natural disaster. So please take a look again. The deadline is July 29th, so you still got plenty of time to get that all together. And one last thing that I also wanted to highlight for those of you that like going to events and like doing hackathons maybe and seeing that kind of stuff, on the Code and Response website right there, John, if you click events, there's an events calendar all the way up at the top that will show you where everything is going on. If there's something you'd like to get involved in, you can filter it out by city. Some of these are online webinars. Some of these are going to be conferences. Some will be workshops, hackathons. Definitely encourage you guys to check that out. There's the one that I know of that you might see some. You could use some of what we talked about today with IoT. Is there's a hackathon coming up this weekend in Fremont, 42 school, I think, for California wildfire. So I'll be there. We're gonna make sure that we're talking a little bit about what we can do with trying to prevent wildfires, and you can apply some of this IoT stuff to this as well. So a lot of stuff there in the events list. So take a look through there if that's something you're interested in participating in. We're always adding events, keeping it up to date to bring you guys the latest events that we have. So take a look through there. So
I tried to maybe there's not a link to it here.
Yeah, maybe that one might be somewhere else, but it is out there. Right. But yeah, all kinds of stuff. So please take a look and get involved. That's all I got, John. Do you have any final parting words?
No. Well, yes, of course. Always register for Call for Code, right? Win $200,000 with Node-RED and with IoT. The team, the IBM Developer Advocacy team, is here to help. If you have some questions and you want some guidance, I would love to talk about IoT. I love to talk about Node-RED. Reach me at my Twitter account. It's at John Wallachy, and find me here. You can ask in the Slack channel. We've got a Call for Code Slack channel. I think there's an IoT topic there, so jump in, post in general, find me as well. Happy to help you win the big money. So, and at the same time, do something really important for reducing the impacts of natural disasters.
Absolutely. And you can find John and I, at the celebration thing and tell us, hey, we remember watching your live stream, and we'd love to hear. We'd love to meet the community. So.
I'd love to hear if we spark some fun ideas.
Well, John, thank you so much for taking the time to go through this stuff for everyone on Twitch and go through stuff with me, because this is stuff, I'm not always in the IoT space, so I learned a good bit from this. I really appreciate you taking the time to do that.
Cool. All right. Thanks, everyone.
All right. Thanks, everyone.
Bravo 6-3.
Okay, test report received. 50% success rate.
We only sent 2 messages, but that's 100%. We reset it.
Oh, you just got another one too.
New message received.
Okay, you're standing at kilometer marker 6.6, which means that the range is 200 meters.
We are about 50 meters behind us.
All right, the moment we've all been waiting for. The winner of the 2018 Call for Code Global Prize is Project Owl.
I would call this a moment of exponential impact. What we're going to do is address some of the world's toughest challenges. The first one is how to respond to natural disasters. We believe it's the largest initiative of its kind. It's something called Call for Code. IBM's committing to take those solutions, the things that you build, and we will deploy them around the world.
I know I speak for all these gentlemen up here that I just really can't wait to get home so we can get back to work on the technology and solutions for the people that need it most. Thank you so much.
La Isla del Cordero. It means Island of the Lamb. Most people, they want to believe that it was not going to hit us. But the night before, we knew it was already on us. During the hurricane, I was helping at 911 center. 911 never lost connectivity, but we weren't able to communicate with the rest of the agencies because they lost connectivity. The antennas had power generators and batteries, but when the power generator ran out of fuel and the battery died, you have an antenna that does not work. Because of all the destruction, the trees, the roads that were closed, it was really difficult to get them fuel. The type of communication that's gonna help you is a solution that you can easily let people know what you need, how you're doing, how's your family, what do you need for the first responders to help you or to bring to your community.
So I could sit in the nest. Winning the Call for Code was such an empowering experience. Not just for myself, but my team. The night we had won, we were all sitting in a room together and we said, we're gonna go to Puerto Rico this spring. We started telling people that the next week and here we are. This was the clearest ground zero for a place that needed our technology. In the worst disasters, like Hurricane Maria, these are typically the events where connectivity infrastructure is most likely to be offline. How do you leverage a sophisticated software system when you have no electricity or internet to do it? We created these little IoT devices called ducts. We turn on these ducts, we put them in an area, and then you can open your phone, connect to the Wi-Fi network that they create, and start talking to others on the network.
What Owl is trying to do with this quickly deployed network is to establish not 100% connectivity, but just bring it from 0 to 1%, which is a huge difference to just get who needs what in a particular community.
A solution like Owl definitely could come in handy in an emergency like the one we had. There are other hardware and software solutions, but this combination of both, it's what makes it different and powerful.
What it takes to actually get Project Owl out there is we need some type of support and help from people who can show us a little bit of a path forward. And for us, that partner is IBM.
Through our Code and Response program, and we're helping Project Owl implement their solution as part of the award for having won the Call for Code competition. We have 5 Project Owl members, 5 IBMers, and as part of that, we also engage implementation partners like IT Disaster Resource Center. They've provided their expertise, as well as co-working spaces here like Engine 4. We see Code and Response as taking these ideas and helping to make them real. Buenas tardes.
Hi, how are you?
Initially, if all you can do is an absolute emergency, you can only send the SOS button, then you press the SOS. Go ahead.
It's hard to sometimes envision what happened here in Puerto Rico. You have to envision a place that had no electricity, no access to roads, no telecoms. It's a unique opportunity to save people's lives, to get them items of basic needs.
This afternoon we're heading to Punta Santiago, so we're going to go into the coastal region, drop a bunch of these ducks, and then start seeing dots and communications pop up on our map.
Puerto Rico, I think it's the appropriate place to test it because we've gone through it. As governor, I thank you, and as a former scientist, I am geekily excited about what you're doing over here.
Awesome. Thank you so much.
Thank you.
This area got heavily impacted from the hurricane. The sand from the beach got all the way down to the roads. It was a lot of trouble. So this will be like the last location.
Yeah.
It's gonna stop right here, and then
and then we're going back.
Then we're going back.
Puerto Rico is really ideal because we have so many different landscapes in such a small place. Having something like this makes it so much easier to get a lay of the areas we're going to go into.
You have mountains, plains, coastlines, rainforests, urban populations, and rural populations, which creates a unique challenge to put a network on the ground, especially if you're doing this quickly and in an ad hoc fashion.
We're going to be going up this road to deploy mama ducks every 500 meters. We're going to test to see if we send a message that it will be able to make it all the way back to the papa duck.
Papa online.
We have this architecture of duck links, mama ducks, papa ducks. Every piece of hardware is the same. The difference between each duck is we write a little bit different code and they communicate in a little bit of different ways to each other. This helps us ensure the function of the network.
So hopefully with this one we should see 100% success when the test report comes.
Yep,
So
awesome.
that's the third message.
This particular test going on here is, can we get a transmission over long range? If we can prove we can do that over a dozen mamas, we're confident we could go from 12 mamas to 20 mamas or 50 mamas. And if we can do that, then we can go from 1 square mile to 10 to potentially 100.
Papa Duck, can you confirm that you received the last message sent?
Location 6 received.
Okay, got it.
Perfect. We've just stuck the duck onto the kilometer marker. We are moving to the next 200-meter location.
There is a lot of humidity in the air, which affects radio frequencies, and also a lot of the buildings here are made out of concrete. So this is probably one of the most difficult areas to do testing with radio frequency technologies.
We need to go grab some Velcro to stick them on some trees. Ducks and trees, who knew?
We developed an app specifically to test if we're connected to the network. You would just press a button, send SOS, message was sent successfully. You can see on screen right here the message ID. There on Derek's phone, we can see that we received the message.
Down in the road there is no cell phone reception. We can't get any messages from the cell phone, but we are getting messages through the ducks.
So this is an interesting application of unintended success of the network. Cell signal does not exist in parts of an area that are being serviced by our network right now.
So it's working?
So it's working.
High five, that was awesome.
Yeah, that was awesome. Hey. Conclusion of the first official field test in Yonis. We did a total of 13 ducks.
Total of 13 ducks,
2.5 kilometers. There was a lot of traffic as well as rain and a lot of humidity. Not the greatest altitude in some hills. There were some issues with the range between the ducks. We'll have to figure out how to optimize that. I think ultimately these boards aren't a final solution. Taking 100 different challenges here to make this network real and to narrow it down to the 2 or 3 key ones, that's what these field tests are really all about.
Overall, very exciting and looking forward to our next test tomorrow.
Yeah, and we couldn't have done this without IBM and the Corporate Service Corps. It would have been a real cluster duck if we didn't have them.
The Corporate Service Corps is a 10-year program that IBM has already been part of. We selected some folks who volunteered for the program with a deep background in user experience, hardware, software, and community building. And so once we got on ground, everybody was very excited to take part of this, but they weren't quite sure what to expect.
None of the team had met in person before, so everyone knew each other from either Slack or just from a name on a piece of paper, someone's qualifications. So the initial challenge was meeting everyone, getting everyone together, getting everyone on the same page.
The CSC people kind of came in and were like, well, what do we do? We're not sure what's going on. It was really up to each individual to kind of define their role and find their niche within the group and figure out where they could best add value to the entire project.
Our personalities really all fit pretty well, I think. The Project Owl team was really cool with all the IBMers. IBMers were really cool with the Project Owl team. That was the initial challenge, to get everyone on the same page, especially technically, because we wanted to make sure that we were playing the right role for Owl, and we want to make sure that Owl was happy with the role that we were playing.
Corporate Service Corps, it's really hands-on experience. It's pro bono. You get to make a tangible difference in the lives of people all over the world.
It was an absolute pleasure to go to the Boys and Girls Club and get an age of users that we don't normally get to test.
The kids just figured out how to connect to the Wi-Fi network. We just asked them, can you find the Mama Duck Wi-Fi? And they just did. I think they know it better than we do.
I am a Hurricane Katrina survivor. I'm from New Orleans, born and raised. My family lost everything in Katrina. I can look at the things that happened to me and my family 14 years ago and the things that happened to the citizens of Puerto Rico 2 years ago, and I am Puerto Rico. Puerto Rico is me. I know what it's like to be forgotten. I know what it's like to think that it's hopeless. I know what it's like to lose everything that you have. I never want somebody else to feel like that, so I will always give back. That's why.
The last digits are 3 Bravo 63.
Okay, test report received. 50% success rate.
We only sent 2 messages, so that's 100%. We reset it.
Oh, you just got another one too.
New message received.
You're standing at kilometer marker 6.6, which means that the range is 200 meters.
We are about 50 meters behind us.
All right, the moment we've all been waiting for. The winner of the 2018 Call for Code Global Prize is Project Owl.
I would call this a moment of exponential impact. What we're going to do is address some of the world's toughest challenges. The first one is how to respond to natural disasters. We believe it's the largest initiative of its kind. It's something called Call for Code. IBM's committing to take those solutions, the things that you build, and we will deploy them around the world.
I know I speak for all these gentlemen up here that I just really can't wait to get home so we can get back to work on the technology and solutions for the people that need it most. Thank you so much.
La Isla del Cordero. It means Island of the Lamb. Most people, they want to believe that it was not going to hit us. But the night before, we knew it was already on us. During the hurricane, I was helping at 911 center. 911 never lost connectivity, but we weren't able to communicate with the rest of the agencies because they lost connectivity. The antennas had power generators and batteries, but when the power generator ran out of fuel and the battery died, you have an antenna that does not work. Because of all the destruction, the trees, the roads that were closed, it was really difficult to get them fuel. The type of communication that's gonna help you is a solution that you can easily let people know what you need, how you're doing, how's your family, what do you need for the first responders to help you or to bring to your community.
I could sit in the nest. Winning the Call for Code was such an empowering experience, not just for myself, but my team. The night we had won, we were all sitting in a room together and we said, we're gonna go to Puerto Rico this spring. And we started telling people that the next week, and here we are. This was the clearest ground zero for a place that needed our technology. In the worst disasters, like Hurricane Maria, these are typically the events where connectivity infrastructure is most likely to be offline. How do you leverage a sophisticated software system when you have no electricity or internet to do it? We created these little IoT devices called ducts. We turn on these ducts, we put them in an area, and then you can open your phone, connect to the Wi-Fi network that they create, and start talking to others on the network.
What Owl is trying to do with this quickly deployed network is to establish not 100% connectivity, but just bring it from 0 to 1%, which is a huge difference to just get who needs what in a particular community.
A solution like Owl definitely could come in handy in an emergency like the one we had. There are other hardware and software solutions, but this combination of both, it's what makes it different and powerful.
What it takes to actually get Project Owl out there is we need some type of support and help from people who can show us a little bit of a path forward. And for us, that partner is IBM.
Through our Code and Response program, and we're helping Project Owl implement their solution as part of the award for having won the Call for Code competition. We have 5 Project Owl members, 5 IBMers, and as part of that, we also engage implementation partners like IT Disaster Resource Center. They've provided their expertise, as well as co-working spaces here like Engine 4. We see Code and Response as taking these ideas and helping to make them real.
Hi, how are you?
Initially, if all you can do is an absolute emergency, you can only send the SOS button, then you press the SOS. Go ahead.
It's hard to sometimes envision what happened here in Puerto Rico. You have to envision a place that had no electricity, no access to roads, no telecoms. It's a unique opportunity to save people's lives, to get them items of basic needs.
This afternoon we're heading to Punta Santiago, so we're going to go into the coastal region, drop a bunch of these ducks, and then start seeing dots and communications pop up on our map.
Puerto Rico, I think it's the appropriate place to test it because we've gone through it. As governor, I thank you, and as a former scientist, I am geekily excited about what you're doing over here.
Awesome. Thank you so much.
Thank you.
This area got heavily impacted from the hurricane. The sand from the beach got all the way down to the roads. It was a lot of trouble. So this will be like the last location.
Yeah.
It's gonna stop right here, and then
And then we're going back.
Then we're going back.
Puerto Rico is really ideal because we have so many different landscapes in such a small place. Having something like this makes it so much easier to get a lay of the areas we're going to go into. You have mountains, plains, coastlines, rainforests, urban populations, and rural populations, which creates a unique challenge to put a network on the ground, especially if you're doing this quickly and in an ad hoc fashion.
We're going to be going up this road to deploy mama ducks every 500 meters. We're going to test to see if we send a message that it will be able to make it all the way back to the papa duck.
Papa online.
We have this architecture of duck links, mama ducks, papa ducks. Every piece of hardware is the same. The difference between each duck is we write a little bit different code and they communicate in a little bit of different ways to each other. This helps us ensure the function of the network.
So hopefully with this one we should see 100% success when the test report comes through.
Yep,
So
awesome.
that's the third message.
This particular test going on here is, can we get a transmission over long range? If we can prove we can do that over a dozen mamas,
we're confident we could go from 12 mamas to 20 mamas or 50 mamas. And if we can do that, then we can go from 1 square mile to 10 to potentially 100.
Papa Duck, can you confirm that you received the last message sent?
Location 6 or 7.
Okay, got it.
Perfect. We've just stuck the duck onto the kilometer marker. We are moving to the next 200-meter location.
There is a lot of humidity in the air, which affects radio frequencies, and also a lot of the buildings here are made out of concrete. So this is probably one of the most difficult areas to do testing with radio frequency technologies.
You need to go grab some Velcro to stick them on some trees. Ducks and trees, who knew?
We developed an app specifically to test if we're connected to the network. You would just press a button, send SOS, message was sent successfully. You can see on screen right here the message ID. There on Derek's phone, we can see that we received the message.
Down in the road, there is no cell phone reception.
Yeah.
We can't get any messages from the cell phone, but we are getting messages through the ducks.
So this is an interesting application of unintended success of the network. Cell signal does not exist in parts of an area that are being serviced by our network right now.
So it's working?
So it's working.
High five, that was awesome.
Yeah, that was awesome. Hey. Conclusion of the first official field test in Jonas. We did a total of 13 ducks.
Total of 13 ducks,
2.5 kilometers. There was a lot of traffic as well as rain and a lot of humidity. Not the greatest altitude in some hills. There were some issues with the range between the ducks. We'll have to figure out how to optimize that. I think ultimately these boards aren't a final solution. Taking 100 different challenges here to make this network real and to narrow it down to the 2 or 3 key ones, that's what these field tests are really all about.
Overall, very exciting and looking forward to our next test tomorrow.
Yeah, and we couldn't have done this without IBM and the Corporate Service Corps. It would have been a real cluster duck if we didn't have them.
The Corporate Service Corps is a 10-year program that IBM has already been part of. We selected some folks who volunteered for the program with a deep background in user experience, hardware, software, and community building. And so once we got on ground, everybody was very excited to take part of this, but they weren't quite sure what to expect.
None of the team had met in person before, so everyone knew each other from either Slack or just from the name on a piece of paper, someone's qualifications. So the initial challenge was meeting everyone, getting everyone together, getting everyone on the same page.
The CSC people kind of came in and were like, well, what do we do? We're not sure what's going on. It was really up to each individual to kind of define their role and find their niche within the group and figure out where they could best add value to the entire project.
Our personalities really all fit pretty well, I think. I think the Project Owl team was really cool with all the IBMers. IBMers were really cool with the Project Owl team. That was the initial challenge, to get everyone on the same page, especially technically, because we wanted to make sure that we were playing the right role for Owl, and we want to make sure that Owl was happy with the role that we were playing.
Corporate Service Corps, it's really hands-on experience. It's pro bono. You get to make a tangible difference in the lives of people all over the world.
It was an absolute pleasure to go to the Boys and Girls Club and get an age of users that we don't normally get to test.
The kids just figured out how to connect to the Wi-Fi network. We just asked them, can you find the Mama Duck Wi-Fi? And they just did. I think they know it better than we do.
I am a Hurricane Katrina survivor. I'm from New Orleans, born and raised. My family lost everything in Katrina. I can look at the things that happened to me and my family 14 years ago and the things that happened to the citizens of Puerto Rico 2 years ago, and I am Puerto Rico. Puerto Rico is me. I know what it's like to be forgotten. I know what it's like to think that it's hopeless. I know what it's like to lose everything that you have. I never want somebody else to feel like that, so I will always give back. That's why being here in Puerto Rico, doing all this work means so much to me.
When I heard about the solution, I fell in love with it. I said I had to be part of the team, but they still have some challenges they need to solve. By building a mesh network, we need to maintain solid network from the duck links, from the mobile phones, back to the Owl cloud.
You can only go so far using radio communications. I think their challenge is going to be finding the right spacing of their nodes in various different, environments. They had great success yesterday. Where they're at today, we'll see. They may learn some lessons and some modifications they may need to do.
Rhea, come in.
Team Alpha, come in.
Okay, 10. Sticking on 10. You guys should go as well. Stop deploying some others.
There we go, it's not going anywhere now.
We're having a couple issues with
The mama's on the ground talking to the papa duck. If there's a mama 100 yards away and she's trying to transmit and the papa's struggling, what we can do is hoist another mama duck up high. Altitude is a huge advantage in radio frequency. She'll hear that message and then from there relay it to the papa duck. This is the one that's connected to the cloud, so this is the most important duck in the system right now.
Yeah, it's like a cell tower without all the expensive construction.
Yeah, costs like $50. That tower probably costs $50,000.
This is a temporary solution, so a temporary tower, if you will.
The way the mesh network's architected, it doesn't matter if we add one mama or if there are 10 mamas there. As long as someone can hear it and whack it, they can keep the message going along.
Well, they're definitely going to be getting better reception off of that.
The goal today is to get a circular loop deployed all the way kind of around this peninsula here. So they're going to be following this road round. So as they come round here, they'll have a direct line of sight connection with our papa duck. The deployment team is currently on this road down here. We can see the live location coming through on the map.
This pole's about to be 150 meters.
Let's just test here. Alpha, did you get number 6?
Number 6 got received, yeah. So we got 19 messages out of 51 that were received, so a 37% hit score, which is not so great. You heard the team asking if the duck was online, so that means that they place the duck slightly out of range. So if they're not getting any signal, they'll move back until they can deploy the duck so they know they're at the edge of the range of one of these devices.
The line of sight range is probably about 400 meters on these devices. Problem is with vegetation, with other obstacles in the way that can affect their transmission range. So this device right now is just slightly out of range from the previous device.
Okay, 35 has been received.
Thank you, Bravo. We just extended our range. We were getting about 100 meters at the top by the power lines, but now that we're away from some of the interference, we're getting about 300 meter range down here.
You received number 0?
Yes, 0 received.
All right, they got it. Today is like an actual deployment. Before, we were just going along one highway, but here we're actually passing through a couple of communities where we would be wanting to provide coverage and allow people to connect with first responders. All right, Duck 20, put down. There we go. This was the biggest test we've ever done. We had cliffs, we had jungle, we had beach.
We wanted to get a 1 to 2 square mile field test. We did that today. The ITDRC set up a grandma balloon that worked amazingly. Everything seemed to fall into place today.
While I was down deploying the ducks, Brian, he was able to see the little dots popping up on the map wherever we were going.
By having those visualizations, it didn't feel like it was this overly technical machine that could only work in a lab environment. It just looked like it was out there on its own working.
Very exciting day, hit a new milestone. Looking forward to the future.
Puerto Rico.
Woo.
Let's go.
You know, actually, I want to show you this one thing. Okay. I really want them to understand that this was so special for us. Oops, that's not it. We wanted them to feel the same way. So we're going to give them these with a little award just to let them know, like, we really understand who you are and why you're here. Look at that. That's your trophy. We're just gonna write on the side, and I have a book for each of them too. It's safe